tính bền vững và dài hạn. Song song với các mục tiêu tăng trưởng và có trách nhiệm với cộng đồng. Vinaconex xây những giá trị, dựng những ước mơ.
Windows Holding được thành lập vào tháng 3 năm 2007 theo mô hình công ty holding nhằm quản lý phần vốn đầu tư vào các công ty thành viên, công ty sở hữu gián tiếp và khoản đầu tư tài chính vào lĩnh vực ngân hàng. Windows Holding có hơn 30 công ty thành viên hoạt động trong các lĩnh vực vật liệu xây dựng, quản lý vận hành trung tâm thương mại, xây dựng, bất động sản, tài chính. Hiện nay Windows Holding đang có trụ sở tại tòa nhà văn phòng Windows Office Building số 2 Tôn Thất Thục, Hà Nội. Windows Office Building được vinh danh tòa nhà văn phòng tốt nhất Việt Nam năm 2018. Công trình có kiến trúc độc đáo, nội thất sang trọng, đầu tư những nguyên vật liệu cao cấp, ứng dụng các công nghệ quản lý hiện đại. Windows Holding luôn tiên phong ứng dụng các công nghệ hiện đại trong sản xuất và thi công, nâng cao năng lực cạnh tranh, dẫn dắt xu hướng, tạo ra nhu cầu mới cho người tiêu dùng, tiếp tục khẳng định vị thế trên thị trường và đứng trong top doanh nghiệp tư nhân lớn nhất Việt Nam. Windows Holding phát triển bền vững.
ここまでの道のり伝えきれない思いと歴史大切なことを忘れずここまで来れた重ね重ねた笑顔と涙I'm here for you いつまでも We are together
trên thị trường và đứng trong
So good morning, dear guests. So good afternoon in Vietnam. Probably Uzbekistan is getting more close to the midday. On behalf of organizing committee and all my Moscow colleagues, I would like to greet you at the opening ceremony of the 23rd International Scientific Conference, Construction, the Formation of Living Environment. Our conference, as you know, was postponed from April, but I'm very glad that we are here together in the virtual space, a slightly unusual format. I hope you can hear and see me well. And before we commence our ceremony, I would like to remind you of their option of simultaneous translating, which is available if you use the menu and the button below. So translation is done into Russian language and Vietnamese language. Okay, so I would like to tell you a couple of words about the procedure of today. And first of all, we have greeting speeches of 4 rectors, and it's about half an hour. And after that, we have a plenary session with 8 or 9 speakers. I hope they're all present at the moment. Through the course of the plenary session, dear participants and guests, you are free to ask questions. Please use the question and answers box below. And don't forget to write to whom this particular question is addressed. Okay, so we are ready to commence, as I mentioned, and hereby I have an honor to give the first greeting speech of today to Professor, Rector of National University of Civil Engineering, and one of the conference co-chairmen, Pham Huy Quang. I apologize if I mispronounce some names, sorry about that. So you're welcome to start.
Microphone.
Could you please switch on your microphone? We cannot hear you, please.
Thông tin ấy, sợ là cái đường truyền qua cái chỗ phòng cabin dịch ấy. Okay, once more again. Tôi muốn nói cái câu đầu tiên bằng tiếng Nga bởi vì cùng host với chúng ta là trưởng Misi, Russia. Уважаемый Professor Pavel Akimov, Rector of Moscow State University of Civil Engineering, Russia. Dear Professor Uktam Umuzakov, Rector of Tashkent Institute of Irrigation and Agricultural Mechanization Engineers, Uzbekistan. Professor Lê Văn Thương, Rector of University of Architecture, Ho Chi Minh City. Professor Lê Quân, Rector of Hanoi Architectural University. Distinguished guests, ladies and gentlemen, on behalf of National University of Civil Engineering, Hanoi, Vietnam, I would like to welcome all of you who attend the International Conference on Advance in Civil Engineering. construction, the formation of living environment 2020 through video conference platform at different locations all over the world. For this 23rd time of FORM News is happy to host the conference and co-organize the event with Moscow State University of Civil Engineering, Tashkent Institute of Irrigation and Agricultural Mechanization Engineers, Universities of Architecture, Ho Chi Minh City and Hanoi, Vietnam. This year is very special because of the COVID-19. So we regret that we cannot welcome all of you at our campus this time. However, our conference would be considered to be very successful since we have attached papers and presentation of 328 papers in 6 sessions with members from 15 countries. We would like to express our great appreciation to our co-organizers for your tremendous support and cooperation. I also would like to thank our great sponsors for your strong and continuous support for us. Finally, I would like to wish you a very successful conference, and we look forward to meeting all of you at the next FORM event. Thank you very much. Большое спасибо.
Thank you very much. So we are ready to proceed, and I have an honor to announce the second speaker of today. This Doctor of Sciences, Professor, full member of the Russian Academy of Architecture and Construction Sciences, acting rector of Moscow State University of Civil Engineering, and also the conference co-chairman, Pavel Akimov. Welcome to speak.
Слышно, что говорит. А можно выступать уже, да?
Да, пожалуйста, начинайте, пожалуйста.
Да, спасибо. Дорогие друзья, сегодня мы открываем 23-ю международную конференцию строительства, формирования среды жизнедеятельности. Эта международная конференция имеет очень богатую историю и проводится на постоянной основе с 1998 года. Она объединяет российских и зарубежных ученых, специалистов, молодых и уже состоявшихся представителей реальной экономики, руководителей строительной отрасли, архитектурно-строительного комплекса. Тематика конференции охватывает основные актуальные направления развития строительной науки и производства. Среди них такие, которые положены в основу названия секции конференции: Reliability of Building and Constructions, New Construction Technologies, Modern Building Materials, Engineering Infrastructure, Management in Construction, Smart City. Национальный исследовательский Московский государственный строительный университет, или сокращенно НИУ МГСУ, активно развивает науку, проводит фундаментальные научно-прикладные исследования в тесном сотрудничестве с учеными всего мира. И хорошей традицией в последние годы стало проведение вместе с нашими конференции вместе с нашими зарубежными коллегами. И в частности, хотелось бы сказать, что особенно приятно, что в этом году соорганизаторами конференции стали Национальный строительный университет Вьетнама, Ташкентский институт инженеров ирригации и механизации сельского хозяйства, Университет архитектуры Хошимина, Ханойский архитектурный университет. В программный комитет конференции в этом году вошли ведущие представители, ученые в области строительства из 18 стран, среди которых Англия, Вьетнам, Германия, Индия, Испания, Италия, Македония, Турция, Польша, Португалия, Россия, Узбекистан, Франция и Швеция. Особенно приятно также сказать, что участниками конференции в этом году стали представители 27 стран мира. Тоже здесь очень внушительный список, включающий Австралию, Белоруссию, Вьетнам, Германию, Израиль, Ирак, Польшу, Россию, Руанду и многие-многие другие страны. Такой широкий охват участников конференции позволяет действительно расширить рамки международного профессионального взаимодействия, ускорить темп освоения новых знаний, сформировать принципы партнерства и повышения уровня интеграции и кооперации в нашей строительной отрасли. Для молодых ученых и специалистов в рамках конференции организован семинар, основным мероприятием которого станет всероссийский конкурс молодежных, научно-технических и инженерно-исследовательских проектов «Молодежные инновации». Проведение такой крупномасштабной конференции, которая является международной конференцией строительства и формирования среды жизнедеятельности, позволяет активно формировать новые представления о строительстве с полным циклом планирования, проектирования, создания, эксплуатации и использования строительных систем, безопасной, качественной, эффективной среды и инфраструктуры жизнедеятельности человека. Я хотел бы особенно сказать, что в связи с эпидемией новой коронавирусной инфекции COVID-19, а также тем, что безопасность здоровья участников находится в приоритете у организаторов конференции, все события нашего мероприятия пройдут в онлайн-формате. И мы надеемся и уверены, что этот формат позволит открыть новые возможности совместной работе сейчас и потом, когда мы вернемся к привычному очному формату заседания, это также будет достаточно серьезный задел для последующей кооперации. Желаю всем участникам конференции плодотворной работы, а участникам молодежного семинара и конкурса победы и новых творческих достижений. Спасибо вам и успехов, дорогие друзья.
Thank you very much for such nice and kind words. And so now we can proceed to the speaker number 3 with a greeting speech. So I would like to pass the virtual microphone to Dr. Vu Ngo Anh, General Director of Department of Science and Technology, Minister of Construction of Vietnam. Once again, apologize for name mispronunciations. Thank you.
Kính thưa Phó Giáo sư Tiến sĩ Phạm Duy Hòa, Hiệu trưởng Trường Đại học Xây dựng. Kính thưa Giáo sư Pavel Akimov, Hiệu trưởng Trường Đại học Xây dựng Moscow, Liên bang Nga. Kính thưa Giáo sư Uktan Umuzakov, Hiệu trưởng Học viện Tiami, Cộng hòa Uzbekistan. Kính thưa Phó Giáo sư Tiến sĩ Lê Văn Thương, Hiệu trưởng Trường Đại học Kiến trúc Thành phố Hồ Chí Minh. Phó Giáo sư Tiến sĩ Lê Quân, Hiệu trưởng Trường Đại học Kiến trúc Hà Nội. Tôi rất vui mừng được thay mặt Bộ Xây dựng tham dự lễ khai mạc Hội thảo quốc tế khoa học và kỹ thuật lần thứ 23 với chủ đề Xây dựng kiến tạo môi trường sống do 5 trường đại học kỹ thuật của Việt Nam, Liên bang Nga và Cộng hòa Uzbekistan đồng tổ chức. Đây là sự kiện về khoa học công nghệ và hợp tác quốc tế có ý nghĩa lớn, thể hiện quan hệ hợp tác tốt đẹp giữa các cơ sở giáo dục của 3 quốc gia. Hội thảo là cơ hội để những nhà khoa học hàng đầu trong lĩnh vực xây dựng, kiến trúc và môi trường của 3 quốc gia trao đổi học thuật, kết nối và tiến tới hợp tác chuyển giao công nghệ. Chúng tôi cũng rất vui mừng được biết hội thảo đã nhận được sự quan tâm của đông đảo các nhà khoa học đến từ nhiều quốc gia, đóng góp những công bố về nhiều chủ đề quan trọng trong lĩnh vực xây dựng nhằm hướng tới mục tiêu đến những công trình thông minh hơn và an
structures and buildings in the future. I also hope that we will have more partnerships like this in the future. The FORM-2020 is organized at a special point in time, given the COVID-19 pandemic, which is hitting hard all aspects of life globally, and it's becoming more important and meaningful with the scientific contribution like this through the conference. I'd like to wish our conference a great success. On behalf of the Ministry of Construction, I'd like to wish you all good health, and members of the organizing committee and speakers of Forum 2020 a great success and good health. Thank you very much.
Thank you very much for your speech. And
Vâng, xin trân cảm ơn đại diện của Bộ Xây dựng.
Okay, so now I can proceed to the ultimate speaker for the welcome, for the opening ceremony. So the greeting word is given to Professor Uktam Umurzakov, Doctor of Sciences and Rector of Tashkent Institute of Irrigation and Agricultural Mechanization Engineers. Yeah. So are you ready? Please start your speech.
Thank you so much. Доброе утро, уважаемые участники и гости конференции, уважаемые коллеги, дамы и господа. Для меня высокая честь приветствовать вас на международной конференции Construction the Formation of Living Environment 2020, которая, как было уже сказано уважаемым профессором Акимом, 23-й раз проводится совместно с зарубежными партнерами. И инициатором этой конференции, как мы знаем, является именно Московский национальный университет, строительный университет. Как было также сказано модератором, нынешняя конференция проходит в необычных условиях, в условиях всемирной пандемии, в формате онлайн, но я надеюсь и уверен, что это не помешает нашим ученым и молодым ученым на высоком уровне провести нынешнюю конференцию. Целью настоящей конференции является модернизация и инновационное развитие строительной отрасли, сохранение преемственности научных школ в данной отрасли, формирование нового уровня подготовки профессиональных кадров, развитие международного сотрудничества, а также реализация научных и познавательных интересов исследователей, экспертов, профессорско-преподавательского состава университетов и самого широкого круга представителей заинтересованного профессионального сообщества России, Вьетнама, Узбекистана и других стран. Весьма насыщенная программа конференции, состав ученых, специалистов, реальная заинтересованность многих коллег на всех этапах подготовки этого мероприятия вселяет уверенность в пользу нашей общей инициативы. Согласно программе конференции, в ее рамках запланированы открытые и содержательные дискуссии по вопросам теории и практики строительной науки на основе современных научно-исследовательских методов, новых идей и подходов к решению проблем надежности, безопасности и эффективности сооружений. Будут также рассматриваться возможности использования и развития современных инновационных комплексов при решении научных и инженерных задач высокотехнологичного развития строительства. Тема этой конференции имеет особую актуальность в свете мировых тенденций в области строительства, науки и образования. Хотелось бы отметить, что современная строительная индустрия – одна из самых динамично развивающихся национальных отраслей экономики Республики Узбекистан, показывающая стабильный ежегодный рост. В последние годы строительство в нашей стране идет очень высокими темпами, как в городах, так и в сельской местности. На сегодняшний день в стране действует более 32 тысяч строительных организаций. По инициативе нашего президента ведутся работы по переводу в электронную форму всех норм и правил градостроительства, по цифровизации процессов экспертизы проектно-сметной документации и хранения заключения экспертизы в единой базе, по контролю за качеством строительства при помощи современных информационных технологий. Запускается единая платформа строительных организаций. Что касается образовательной и исследовательской составляющей, то процесс интеграции различных уровней и организационных форм образования и науки – это тенденция, которая постепенно охватывает все страны мира, в том числе и Узбекистан. И не случайно в последние годы много говорится о создании форм, которые могут объединить научно-образовательный потенциал. Важно осознать, что подготовка высококвалифицированных специалистов – задача не только отдельно взятого учебного заведения, а всей образовательной системы и, в первую очередь, заказчиков, то есть производственных отраслей. Именно поэтому одной из миссий нашего Ташкентского института инженеров ирригации и механизации сельского хозяйства является объединение людей вокруг общего дела, тем самым формируя поле для обмена мнениями, знаниями и взаимного сотрудничества. С абсолютной очевидностью можно констатировать, что роль и значение вузовской науки с каждым годом растет и будет расти, выражая уверенность в том, что конференция станет одной из площадок для демонстрации ведущими учеными и молодыми исследователями достижений мирового уровня, будет способствовать укреплению академического сотрудничества, а ее результаты, я уверен, найдут отражение не только в формате международной публикационной активности, но и на уровне дальнейшего воплощения в жизнь в реальных строительных проектах. От всей души желаю вам успехов и эффективного научного сотрудничества. И, конечно, как уже было сказано, в условиях пандемии желаю всем быть здоровыми. Благодарю за внимание.
Thank you very much for your speech, and yeah, thank you. And now we are ready to commence our plenary session. I will be announcing the speakers and the topic of their reports. And once again, I would like to remind for the speakers and for the guests and participants that so it's about 20 minutes allocated for each report. And if we have some time left, you are free to ask any questions and the box Q&A question and answers below. Okay, thank you very much. And I'm happy to announce the first speaker, Associate Professor Nguyen Quan Dhan, Vice Rector, National University of Civil Engineering, Hanoi, Vietnam. And the topic of his report is Development of Management Policies and Advanced Technologies of Construction Demolition Waste, a life cycle approach for sustainability. Please, if you're ready, you can comment now. Thank you.
So, ladies and gentlemen, I'd like first welcome to the International Conference of FORM-2020. It's my great honor today to attend this event and also to be the keynote speaker. This is my great honor, and I hope that you all enjoy my presentation. So, em ơi chuyển cái giúp cho mình cái slide mình. So my presentation today is about the development of the management policy and advanced technologies for the construction demolition waste, the life cycle approach for sustainability. So this is the very important topic here in Vietnam nowadays, that we focus in the recycling of the material, especially for CDW, in order to save the environment. So as you may know that in Vietnam, so we generate quite a big amount of the CDW because with the very fast growing economic of Vietnam, so Hanoi and Ho Chi Minh City alone, so each day generates about 2,000 to 3,000 tons of the CDW. Other cities like Da Nang or Hai Phong also generate around like 500 tons per day of CDW. So it's a huge amount of CDW in Vietnam. So as you may see, this gonna cause a lot of issues and problems for the cities. So with the environment issues and cities and also urban planning and development. Because of this, so we have to look into the situation and find a solution for these issues. Currently, the CDW in Vietnam, we just use mostly for the bricks, but very, very simple methods. Or also we just use for backfilling. So it's not very effective apply. So we look into other countries, for example, like Japan. Japan generates and also recycle about like 99% of the asphalt or concrete, while in Vietnam, just around like 2%. So if we consider CDW is waste, it's just waste. But if we consider CDW as resources, so we can reuse and use these resources to generate economics and also to apply in the social activities. So for Vietnam, the national environment policy up to 2025, Vietnam targets that we're going to collect around like 90% of the CDW, and also want to reuse 60% of this. However, it's not easy to get these targets from current situation of Vietnam. So we look into this situation and we want to find the management policy and also advanced technology, how to boost this collection as well as also the recycling. So in my presentation, first I mentioned about the development of management policy. This is the very typical management policy here in Hanoi in Vietnam. So the government, the central governments like MOC, Ministry of Construction, is the one in charge of the CDW, and also cities like Hanoi, together with Hanoi Department of Constructions, gonna manage all of the CDW until with the districts and to the project owners. So they have to report to the DOC and to report to the PC every year about the activities. So each year, MOC also evaluate about the CDW situation. And recently, MOC also issues the decree number 8, in which to support for the recycling of this as well. We did also the survey in Vietnam for the 56 contractors, and we survey in Hanoi, Ho Chi Minh City, and Hai Phong. So this is the very typical methods that we demolish here in Vietnam. So this is a very typical building. This is a typical building where we want to demolish. And this is, I'm sorry, I have to go here. So this is how we demolish currently here in Vietnam. And the typical methods is we remove all of the interior and also including the concrete, and in the CDW including others like steel reinforcement and also slab as well. So we did the generate, and this is a typical management methods here in Vietnam, that furniture and other appliances that we can reuse. This one to be sold to other companies. But wood and also glass as well, also we can sell to the scrap buyer. Steel is not considered to be the waste. Steel is the material, so we can recycle. But others like concrete, brick, mortar, or tile, that currently we do not have the proper methods to manage as well to reuse. So very large amount of this now just dumped illegally. So that's why, for example, like in Vietnam, if you go to Hanoi or big cities, sometimes you see very just big amount of CDW just dumped on the side of the road. So it's going to be a big problem. So we survey for these methods, because we have the current new circular number 8 here in Vietnam. We survey with contractors, so we find that the awareness of the policy is not very clear for the contractors. So some contractors like just very slightly aware of the management from Vietnam. So this is that where we have to improve of the management side. And also we survey with the reason and how they're gonna want to recycle CDW. So the big concern for the contractor is about the cost increase. Currently, just CDW just dumped somewhere, so without any cost. But they worry if we do the CDWs, the cost going to be increased. Who's going to pay for that? And also we do not have enough of legal guidelines. And also we do not have the treatment facility properly here in Vietnam. Currently in Vietnam, we don't have any facility to do this work. So that's why the recycling rate in Vietnam is quite small. So our project, we would like to overcome these issues. So we want to develop the management policy as well for the CDW. Sorry. Sorry. With it. Okay. So we establish the research projects. So in this research project, we not just only focus on the technical terms and technical sides. We want to collaborate with the government to implement the management policy together with the technologies in order to manage and also recycle CDW. So in these projects, we work together with the Japanese side, Japan government, and also Vietnamese side with Ministry of Constructions, Ministry of Environment, and also other local administration as well. So where we focus to issue the guideline standard with the government, and also together with other research partners like Hanoi University of Science and Technologies, we develop new materials in order to apply and generate the profit. So from Japan side, because Japan has a lot of experience in recycling of this material and overcome these kind of problems. So we collaborate with Japan and together we want to develop this model. It's not just only for Vietnam, but hopefully for other developing countries as well. So the way that we approach just from the circular economy built environment, we want to focus to develop the model that not just to generate about the technical results, but also to approach from the sustainabilities to generate just profit. So the private sectors, companies can join with us and they can continue to develop even after the research project finish, and they can continue and for the long-term development. So we want to minimize from the very beginning for the design, minimize the construction waste, and also for the proper management of the demolition waste. And finally, we want to recycle it. So anything generated from that, we would like to recycle and to generate. So we, in order to get to that levels, we divide it into 4 activities. The first one that we want to develop the guidelines for the well management of this area, because currently in Vietnam in general, because we do not have the guideline how to demolish the old buildings or structures. So the contractor themselves just do not know how to follow the proper way. So that's why we develop the guideline together with the government. So we want to have them to know how to transfer and also to the facility as well. And the next one, we want to develop the technical instruction and standards, because in order to apply it into the practical work, we need the national standards. So they know how to just evaluate and test for the quality of the CDW, so everyone can apply it. So we develop the technical standard, the national standard, as well as a partner, especially with the government. And the activity number 3, where we focus for the new technologies. This is where we add the value for the research to make the new materials, so that can generate profit for the sectors who participate. We focus in 2 main sectors. It's like wastewater treatment system. That way we can use CDW, and to develop the permeable payment system as well. And finally, for the long-term development and sustainable development, so we want to make it into the business model, so the private sector can join with us to recycle CDW. So they themselves can develop technologies. And like themselves to collect and to recycle. So we will develop the business model for recycling of the CDW here in Vietnam. In our projects, because the project currently we focus in the big cities like Hanoi. We did the survey here in Hanoi. As you can see, this is Center Hub in Hanoi. Hanoi already we have the design, the landfill for the CDW. So just around the area, just here. And this is a typical one, for example, like Thanh Trì landfill, and also in landfill in Hanoi. So you see, this is already full. It's very difficult to add more CDW here in this area. So the landfill area is no longer available. So we want to develop the management and technology to recycle this material as well, and also for the coming CDW that every day generate, for example, in Hanoi about 2,000 tons. We also investigated in landfill in Haiphong. So this is the where we did in Haiphong at some location there, but actually Haiphong also now they do not have any design site for landfill, so also very big issues. So we want to work with them to help to develop for the landfill in Haiphong. So the CDW just only dump somewhere. This is survey that we did, that is our activity number one. And activity number two, that where we develop the national standard of Vietnamese standards. So everyone on the same page, we know how CDW is going to work, how to evaluate with the tests, and to the acceptance and testing as well. So we formed the team, Vietnamese team, and also Vietnamese and Vietnamese Japanese experts. And we survey in Hanoi and to find the generate amount of CDW here in Hanoi and also other cities. So we come up with the coefficients for the private households and so office household as well. For example, like 1.39 tons per meter square that we generate. So from now, any buildings before the demolition, we can calculate the amount of the generated CDW, because in the circular number 8 from the MOC, we need to submit the estimated quantities of CDW. So this equation, this amount gonna help them to evaluate, to estimate about the amount of CDW. So this is very interesting. And also for the existing landfill in Hanoi are being threatened to be shut down because already over very full, cannot accept more CDW. So we investigated the current, the CDW, the bearing capacity. So this is the results that we got. The varieties of the materials for aggregate to fine and other material as well. So this is going to be interesting. Now we are being tested for this material, to recycle this. But this is very typical because in Vietnam, because we do not have the guideline yet. So the CDW here in Vietnam, like it's mix of the aggregates, also concrete, bricks, and also tiles and everything. So that makes the recycling very challenging. So that's why we need the proper guideline, to separate for the CDW just at the side and transport to the facility in order to recycle it. So in order to make the proper recycling, we need to develop the advanced technology. So the first side that we focus on the management side with the government. But the next part, we want to develop the advanced technology. So this is where our projects, we establish one lab, what we call the SATREPS lab, where we develop just very advanced equipment together with other pilots project. But the equipment itself that we develop together with the Japanese partners, we want to focus on the research development. And what we want to do is to add the added value for the materials of the CDW to make it become valuable. Currently, without any proper treatment, CDW just dumped somewhere. without any technical standards. So it's very difficult to accept for the projects. So we have several applications. First one that we want to use to separate the oil, the oil polluted water, just especially for the sea area in Vietnam. As Vietnam, because we have the very long coastal borders line, so we want to focus to treat for this one. We want to use CDW to combine with other materials to absorb and separate oil in the sea waters. And the second application that we use these CDWs for the base, sub-base of the payment, as well as we want to develop the in order to reduce the water flooding in, for example, like big city like Hanoi and Ho Chi Minh. So we hope that the materials, new materials, gonna absorb the water here. So to apply for the roads or payments, or so the water can absorb to the ground level to keep the water ground level, because currently we with the after the big rain, so the big city is going to face with the problem of the flooding. So we want to support for the flood control, and also this kind of application can consume very big amount of CDW, so that we can help for the recycling of this material. So we are now developing this in the lab, as well as we have the TCVN for accepting of the base sub-base. So it's going to be available at the end of this year. Also, in order, as I mentioned, that in order to make it sustainable, we hope that to develop to work with the industry. So in these projects, we work with the private sectors in Hanoi that we develop with, for the one side. We call the facility for treatment CDW. Is the first one in Hanoi. Together with them, we developed the pilot of the crushing machine. And these materials, going to use material here in Hanoi. We separate and we're going to test in our lab, and to get the proper spec for this material to be accepted for the project and also as well. So this is the general view that we want to develop for our activities. From the very beginning, we want to just optimize for the design of the building, as well as we can estimate for the CDW generate from any buildings that going to be demolished. So we can estimate about that amount of CDW, and we're going to make the plan, and we work with the contractors. In order to help the contractor to work properly, we develop the new guideline. So that's where we want to help the contractor to separate concrete, bricks, and other steel glass with the proper way. And also we support for the transportation methods, how to transport, because it's important that this material transport properly and it doesn't make any issues for the environment. And we develop the technologies that going to use for facilities here in Vietnam that concentrate for the recycling of CDW. And these materials, after recycling, that we now developing the standards. So this material can have the testing methods, quality controls, and also how to know how to accept for the practical projects. So this can help to generate profit. So this is going to generate profit, so private sectors can join, and also the business can develop. So this is the circle that we want to develop. The business of company, and then again, they're going to join and start again with other projects. So the concept that we want to do is that we want to help with the management. We want to help with the policy, and we want to make it sustainable. We want to make it circular, that in the future, this technology itself can self-develop. And then we hope that to generate profit, not only to bring with the advanced technology for the scientific approach, but also we want to bring for the economical and also business model for this area as well in Vietnam. So this is this is the presentation of my presentation with this is the active for the group. We have a very strong group. Everyone works together. Many of them are here. So I'm very happy to have these opportunities to work with them and also to present today. So thank you very much.
So thank you very much. We have a question to the speaker, which arrived in our question and answers box. So the question is, in your opinion, companies involved in waste processing should be supported by the state or become self-sufficient?
Thank you very much for your question. So the company itself should be the private, so they can self-operation, but the government manage and also control for the policy, because in order to make sustainable, the government should support for policy to help in many construction, especially the projects related to the government. So they have the policy to encourage to use the CDW materials in those projects as well. Also, we work hopefully to support them in other kind of like tax and also other system as well for them, that they encourage them, especially from the beginning, to join in this industry, and then they can generate profit. So the company itself can be private, but the government going to support, and the standards, the national standard, going to help them to work with others under the same page, that for the quality control and acceptance as well.
Okay, thank you very much. And we have the second question. I think we have time to answer. The question is, do you think about what do you think about modernization of materials, and how will the new materials affect your methodology? Thank you.
Sorry, could you come again with the first one?
Yes, please. What do you think about modernization of materials, and how will the new materials affect your methodology? That's exactly the formulation.
You mean that the durability of the materials? Did you mention that?
No, durability, no, only about modernization. I can only read the question. I don't know who is the person asking them, unfortunately.
Tức là hỏi xem, do you think about the modernization materials? How will the new material affect the material? Yes, thank you very much. The material itself is like quite tradition. So we want to modernize, like we want to add values in these materials, because as you know, like currently in Vietnam or maybe other developing countries, this material is not treated, just dumped. But now we want to change the concept. This is not waste, this is resources. So that's why we use methods that we want to add value in these materials. For example, like as mentioned, this material that we're gonna recycle, for example, like aggregate for other concrete applications. And also we use fine parts aggregate to make the synthetic aggregate to apply for some proper application project as well. And also that we want to use some bio materials to make new materials to use for other, it's like for oil separation or absorption of the oil, contaminated oil in the seawater. So we want to make this material become the modern and also value. So including the just the added value from the knowledge, so that is become valuable as well.
Okay, thank you very much. And because we still have some time left, one more question, probably the ultimate one. The question is, what kind of management technologies do you recommend for developing countries with less skilled personnel? Thank you.
So you want to make our recommendation of the management for other countries that may be in the same situation, right? Yes. Actually, because the scheme of our projects, what we call satraps, is that it's not just suitable for one areas, for one local administration or just one country. So we want to make it typical for any countries that gonna face the same problem with us. So that why we want to approach from the overall approach that first come with the policy, that we investigate the situation. And then we gonna recommend for the policy how to support for this technology to develop. We understand that each areas gonna have with different materials specification. So for each area, they have to investigate the material, the CDW themselves at the areas. But we develop the technical terms or standards that they can follow to check for the properties of the materials. But the approach would be the same, that they can come from the policies, develop the materials, and these material in general can be applied quite similar, like for the base, sub-base abroad, and also going to use for different also application as well. So definitely already we think that this approach can be suitable also for other developing countries, especially for the business model as well. So we hope that as well this can be the typical one for any country that want to face same problem with us. Thanks.
Okay.
I'm sorry, I have one question from Vietnam. Is this okay that I answer the question here?
Oh, yes, probably. Yes, it's no problem. We still have 5 minutes. Yeah, thanks.
Hello, I am Chang from Suez. So my question is, which legal or scientific references you use to build the management policies? And the second question is, what kind of the concept of collaboration between the private company and the government you are proposing?
Thank you very much for your question. So the first one is about the legal framework that we're going to use to come up with the kind of proposal. Because first we come with the environment national strategy from the Prime Minister. That's until 2050. That this national environment strategy is already very clearly mentions how we're gonna solve for the solid waste, including CDW. So this is very important that we have the direction from the government, that what we should focus. And secondly, because of the Ministry of Construction recently already issues the circular number 8, in which require any cities in any province, they have to report, manage, and also collect and reuse the CDW. So this is important that all the province and cities should follow the circular from the ministry. But the thing is how to make it like effective. So that's why our project to help the implementation of circular number 8 to be implemented properly. So that is a very important legal framework that we base on to come up first with these projects. And the second one is about the collaboration between the government and also private sectors. It is important that it's still now already that the private sectors have to report to the local government about the recycling, collecting, demolition of the CDW. But the thing is that it's not proper implementing very well. Still, we see a lot of dumping of the CDW illegally, and also the recycling rate is very low, just 1 or 2%. The problem is because the connection, and also the companies, they do not have any guideline, know how to do it. They don't know that they can make money. So that is the thing. And also the government, still they need very strict management policy, because we visited other countries like Japan and others. It's very important that you have to treat the CDW properly. If you dump somewhere, your company is going to be very severely punished. So they cannot do that. So our project, we want to develop the legal framework, including the guideline, standards, and support, so the company knows that if they follow, they have the proper technology and policy to support them. And then the government going to tightening the policy, so that both gonna come together with the policy and also the technology. So this is the answer. Right. Thank you. So I think the time is up for me.
Thank you very much. Yes, it's perfect timing. Okay,
thank you very much.
Right. Thank you.
Thank you.
Now we can proceed to the second speaker in our plenary session, and I would like to pass on the microphone to Professor Viet Anh Nguyen, Director of Institute of Environmental Science and Engineering, Hanoi University of Civil Engineering, Vietnam. And the topic is measures to combat emerging environmental problems in urban and industrial areas in Vietnam. Thanks very much.
Hello, good afternoon. Can you hear me well? Hello, добрый вечер. Вы слышите меня?
Yes, we can hear you quite well. Thank you.
Хорошо. Ladies and gentlemen, good afternoon. This is my honor to share the latest results of our research in the measures to deal with urban waste. We are looking at similar vision, circular economy, but we are looking at how the solutions, how to deal with wastewater sludge and septic tank sludge in the city. We don't see the slide. Can we move the slide on? Yes. Because of time limit, I will highlight the situation and solutions we are looking at for the cities and not for industrial areas. I will highlight overview of urban water and wastewater in Vietnam cities, some urban design to deal with stormwater. We will talk a bit about the integrated waste management solutions for the recovery of the resources. Some case studies and conclusions. Let's look at the overall picture of the water and wastewater situation in Vietnamese cities. Up to July 2020, we have about 840 cities and towns, and this is about 39% of population in the city. And daily, the cities consume about 10 million of cubic meter of water, supplying to around 90% of population. And it generates a lot of wastewater to be treated. The leaking, the non-revenue water percentage is about 21%. This is a lot, but this is already a great progress compared to the previous decades. And the average water consumption is 110 liters per capita per day. Many cities in Vietnam are still suffering flooding, and there are a number of reasons of the city flooding, including inadequate urban planning and planning implementation, improper management of the leveling, ground level of the city, clogging and poor maintenance of the sewer and drainage lines, and so on. And because of the climate change, the coastal cities are also suffering the problem of the tide level rising and change of the rainwater patterns. Besides, we also have some reasons like poor public participations. So somebody dumps solid waste into the sewer lines, and the poor connection of the sub-basins, downstream and upstream sub-basins areas, and misunderstanding and wrong strategy to deal with the floods. So we need not only proper engineering solutions, but also proper management, and we need more environment-friendly solutions to deal with. So now, green city and green buildings is a very modern trend, and this is a very good trend, as it brings a benefit, sustainability to the development. And we have to mention that the construction plays a very important role in the climate change and in the CO2 gas emission. We know that construction brings a major contribution to the socio-economic development, but the construction contributes around 25% of total CO2 emission. And it is more than any other industrial sector in the country. And construction areas consume about 30 to 40% of the energy, and 20% of global water demand, and 50% of raw materials is consumed in the construction area. So if we apply the green solutions in the construction, we gain a lot. So the worldwide practice recognize the key aspects of the green cities, including 12 key aspects. And here you see the majority, a lot of them, we are talking about the resource recovery and less consumption of the materials and the energy and water and so on. And in the green city, green buildings play a very important role. There are different rating tools to rank, to recognize, to confirm is it a building green or not. And we are talking about the 5 key elements of the green building, including energy conservation, water, materials conservation, site impact, and indoor quality of the environment. And besides, we also encourage the innovation in the design, construction, and operation. Among well-known green building rating tools, Lotus is a commonly applied rating tool in Vietnam, and we also very much encourage the energy and resource conservation, including water and materials. And it brings benefits. With the green building solutions, we can make the profit, we can save the operation expenses for the building. And I will highlight the green building solution relevant to the water. This is sustainable urban drainage solutions. Since we are suffering the flood, we can mitigate the impacts of the flood if we can slow down the flow of the rain, make it reach the sewer lines, reach the river in the slower modern. So by different meanings of the urban planning, infrastructure design, building development, we try to retain the flow, and it helps to reduce the diameter of the sewer lines. It helps to mitigate the flood. It helps to utilize rainwater for groundwater recharge and for utilization for different purposes in the city. And by doing that, we can save water exploit from the water sources. This is some examples of the sensitive urban design and rainwater harvesting in Korea, where in the new urban area in Korea, in Seoul, they harvest rainwater for different purposes used in the buildings. And because they have to spend more money, the city gives them a right to build more 5 higher floors. And it makes a win-win situation. And on the right hand is a green park applied in Bangkok University, where they harvest rainwater, store in the underground tank, and they use it for irrigation and for landscaping. And this became a very attractive park right in the city. In Vietnam, we have also some good cases. Eco Park in the north of Vietnam and Phu My Hung new urban area in Ho Chi Minh City with a very large area. And the value of the real estate is become high thanks to urban sensitive design and encouraging water in the area. Within University of Civil Engineering, we are also doing research in rainwater harvesting, and we have one pilot, green roof. Green roof can help you to mitigate the flood impacts because it retains the flow of the rain. It can reduce the heat for the upper floors. It can provide some flowers, vegetables for food in urban agriculture, and positive benefits for the landscaping. We also did some calculation to see the benefit and cost of these green solutions, which are very much potentially applicable. Now let's talk a bit about the wastewater. As I mentioned, about 10 million of water is consumed in the cities, and it generates more or less 8 million of the cubic meter of wastewater from the city just for domestic. And the specialty in Vietnamese city is we have most of septic tanks. And then we have combined or separate sewage systems. And septic tanks generate a lot of sludge, and we have to deal with the sludge. And so far, we have about 120 wastewater treatment plants in the cities in operation or under construction, treating about 15% of wastewater so far, and very near future, 25%. And over the last 5 years, approximately, we have spent $1 billion of US dollars only for the wastewater sector in urban areas. We are using mostly activated sludge process. This is a biological treatment processes for wastewater treatment, and private sector is starting to come into the field. These pictures show in operation wastewater treatment plants in different cities in Vietnam. The first treatment plant has been built and started in operation in 2005. And over last 15 years, we have more and more wastewater treatment plants put in the operation. And this is the latest one in our cities. We have a lot of challenges we are dealing with now in wastewater treatment in cities, including combined sewage system, which is not stable, not with a high fluctuation of the characteristics and flow patterns over the seasons. We have limited household connection, which we have to involve the household into the projects. The resource recovery, which I mentioned, still not being well considered, and this is one of my message I want to deliver. And the government is going to issue the new environmental law probably at the end of this year, where we have to impose the new rule where wastewater have to be paid for the collection and treatment fees to reach the full cost recovery for the wastewater management in the city. In the wastewater management in the city, a lot of sludge is generated. This is a secondary pollution source. But in the sludge, it contains also a lot of valuable materials. Similar to the previous speaker mentioning about the demolishing waste. In the sludge, we have also good materials for nutrients, for fertilizer, and we can recover energy from the sludge. So we have to think of how to deal with the sludge when we are talking about the wastewater management. And there are different ways to deal with the sludge, where we can make the energy from, we can make the production, construction materials, and fertilizer. And the septic tank sludge, which I mentioned, significant amount of septic tank sludge is generated. Every year in Hanoi, about 500 tons of septic tank sludge is generated. And it's dumped somewhere. Only 10% of this type of sludge is properly managed. So in order to find the right solution to deal with this type of sludge of waste, we have to understand the flow. Where does it go, and what is the characteristics? So we did this study. We call it waste or sheet flow diagram. You see the green arrows go to the treatment and utilize just a small fraction, where the majority, the red lines, go to the environment without treatment. So if we can deal with these red lines, divert it into the resource recovery, we can mitigate the pollution and we can make a benefit for it. So we go to the next step. We try to characterize these waste flows from the city, including sewage sludge from the wastewater treatment, including septic tank sludge, and including municipal solid waste. The solid waste from the city contains a lot of organics, and from the organics we can make the fertilizer or you can make the energy. So we did the characterization of this waste fraction, and we bring it to the laboratory. We try to send it into the anaerobic digestion reactors and try to recover methane. You know that from the anaerobic digestion, we can recover CH4. This is an energy source. This is a fuel. So over the last 10 years, we did a number of studies in the waste to energy direction with different fractions of waste from the city like this. And this shows some results of anaerobic digestion characteristics of these waste fractions, where we see the microbial community in the anaerobic digestion reactor. This is a biological treatment process. This is how much we can gain the methane from each volume, each unit weight of the waste of the sludge. For example, from 1 gram of the organic fraction of the sludge, we can gain from 240 to 400 milligram milliliter in norm conditions of the methane. And this is energy, this is money. And we did some case study for one urban district of Hanoi City. We took Long Biên district for the case study with 350,000 population. And every person every day generates about 1.2 kilogram of solid waste, 160 liter of wastewater, and we did some scenarios of wastewater management. The first scenario, sewage sludge is dewatered and then dumped to the landfill. The organic fraction of waste is sent to the composting plant and used for fertilizer, and no energy recovery. The scenario 2, we send all the fractions of waste to the waste treatment center, where we send it to the anaerobic digestion reactor, from where we can recover the methane for making the electricity and heat. And we did the flow calculation, and this is a simulation we call material flow analysis, MFA. And we can estimate how much waste is generated, how much energy, where to go, depending on the scenario, depending on the methods we are dealing with the waste. And from the right-hand side, the diagram, we call it energy balance. We can see if we bring this fraction of waste to the waste treatment center, we can have self-sufficient waste treatment center. So it doesn't need energy supply. It can provide energy for itself. And also it can send exit electricity to the grid and send the exit heat for utilization for selling. And we did the calculation for 1 person per year. We see that embodied energy in the waste fractions. We are talking about the chemical energy. Besides, we also have the dynamic energy potential and temperature and wastewater where it has a heat, we can recover energy as well. But the chemical energy embodied is most important. So we found every year, one person can generate from solid waste and 159 kilowatt hour, taking the Hanoi city conditions. From the fake and sludge, we have 1.5 kilowatt hour per capita per year. And from wastewater, 15 kilowatt per capita per year can be recovered. Based on this, we can have some conclusions. So if we deal with the solid waste in a proper way, we can mitigate the negative impacts, protect the environment, and make the benefit. And it should be done from the early planning stage, and then we can maximize the benefit. And this is our scheme. We are going to, we are presenting, we are suggesting to realize a circular economy in the waste management for Vietnamese cities, for recovery of energy, for utilization of the nutrients for fertilizer, for construction materials, and to realize a circular economy for the smart and green city. And of course, for doing that, we need to look not only at the technology, but we need to we have to deal with multi-dimensional aspects, including public involvement, private sector participation, urban planning standards, and so on. So that is my presentation for today. And I would like to acknowledge the international cooperation and national research projects where we could get the support to have the very good and reliable and promising results. Thank you very much, and спасибо за внимание, and welcome to Vietnam.
Thank you, Professor. We have one question which was received during your speech. The question is, do you have any analytical or numerical models of water flow in relation to the location? Thank you.
Again, can you come, please? I just heard the second half.
Okay, so sorry, no problem. Do you have any analytical or numerical models of water flow in relation to the location? Did you get me?
Yeah, if I understand right, we are using the flow simulation, and you have the material flow analysis where we can quantify on the fraction of waste depending on the input data from the number of populations, the unit load of the waste. We can quantify the flow, and depending on the scenarios, we can estimate how much we can gain the resources and energy, etc., from each scenario. So we call it material flow analysis and energy balance analysis.
Okay, thank you very much. Any more questions probably from the audience there in Vietnam? I don't have any internet question, no more.
Yeah, if you still have time, I have one question.
Oh, yeah, yes, we still have about 7 minutes. Yes, please.
My question is, what is the challenges for the private sector to join in the urban wastewater management, especially the BT projects?
You're asking about the
challenges for the private sector.
I think this is a very good question. And the policy of the government is to encourage private sector participation in the waste management, because now, so far, 80% of the money spent for the wastewater management in the cities came from the ODA. And we cannot borrow in this way money from abroad anymore. We have to pay back the loans, the interest rates. And when Vietnam came to the middle income countries, the interest rate is not favor anymore. So private sector participation is a way to mobilize different resources. But private sector comes if they see the benefit. And the wastewater doesn't make the benefit for the company. This is, we can have the indirect benefit if we protect the environment, if we can make the good socio-economic condition for the growth. So we need the right policy to give, for example, private sector spend money for wastewater, they can have other favor conditions for real estate development, for example, and the tax policy and some other, we are doing that. And we have already some examples where private sector came to the BT project. BT is the most feasible way to do. Now we encourage BOT, BOO models. That is for wastewater, but for solid waste, we can do it. For solid waste, there are already, I can give you the number, more than 30 projects in the waste to energy direction in Vietnam. And some projects already almost they are finishing the construction and put into operation very soon to make electricity from the waste, from the incineration. But it requires a lot of investment and the unit cost is very high. So we are proposing the anaerobic digestion and biogas recovery. We think this is more sustainable and we don't have to deal with a lot of ash, which is also the problem of the secondary waste. Okay, I think I'm done. Thank you very much.
Okay, thank you very much. So thank you. And so now we are ready to announce the third speaker for today. I think he is present in the audience, in virtual audience. It's Professor Ninoslav Marina, PhD, Rector of the University of Information Science and Technology, St. Paul the Apostle, Ohrid, Macedonia. Good morning or good afternoon, so whatever is time in Macedonia at the moment.
It's actually good morning. Чао Буисанг, Вьетнам. Доброе утро, уважаемые ректоры, уважаемые профессоры, уважаемые коллеги. It's morning in Macedonia. It's 1 hour before Moscow time. And it is my great pleasure to be with you here. I would like to share my screen. Can you hear it? Can you see it?
Yes, it's all fine. Perfect. Thank you.
Okay. I just wanted to check that everything is fine. Okay. Thank you very much for the introduction. Thank you very much, everyone, for inviting me to be here with you. I'm coming from a different area. It's a big pleasure to be with such important universities. I'm telling on a global level. I visited almost 2 years ago the Moscow State University of Civil Engineering, and they are my good friends now. They invited me to see what will be the synergy between your very important area of construction, so many important things around us, and how the future of information technology and information science and technology more precisely will help in this construction area. So I'm coming with one topic which is rather new, but I'm happy to see that there is another talk related to the blockchain technologies in real estate at this conference. I would like to see and share with you what are the trends related to the real estate and to the economics around real estate, more precisely selling and buying, and how these future new technologies can be used for facilitate that. I'm coming from a very small university, University of Information Science and Technology, St. Paul the Apostle. It's in a very small town, Ohrid, in a very small country, Macedonia, but we are very international. Recently, we graduated one student from Hanoi, from Vietnam. He received his master thesis, and he continued his PhD in Berlin. We also had Russian students and professors, so we are quite international. It's a big pleasure to be with you. Unfortunately, I cannot be personally in Hanoi, but I promise to visit as soon as it is possible, whenever everything comes back to normality. Just one share of Ohrid. Ohrid is, as I said, a 40,000 people town, but it's quite beautiful and important. It's one of the rare sites that is double UNESCO protected for the natural heritage because of the Ohrid Lake, and for the cultural heritage because of the old city of Ohrid that has a long history, especially very important in creating the Cyrillic alphabet that is, as we know, official alphabet in many countries, including such big countries like Russia. So what is the motivation for my talk? I was working extensively in these blockchain technologies recently. I would like to see how blockchain technologies can help in the so-called real estate technology or property technology, shortly called PropTech, to make all these transactions more efficient, less expensive, and then offer a lot of creativity in terms of offering new business model, how to sell the real estate, not only just selling the pieces, but you can imagine all possible time sharing and renting, and all these transactions will be much easier using these future technologies. Actually, the idea is more general, to use technologies like in general in the real estate, but we notice that these particular blockchain technologies are quite helpful here. Many people, when we mention blockchain technologies, they think usually they think about cryptocurrencies, most notably about Bitcoin. And whenever you ask people about that, or you tell people about these ideas, they think about cryptocurrencies who are very speculative, very volatile, not stable. People are suspicious. They think what's going on behind, wasting energy, all this like proof of work and stuff with the big farms that mine Bitcoins, and maybe you've read some illegal trade behind that. But when I say blockchain technologies, cryptocurrency is only very small part of it. Blockchain technologies is very disruptive and new technology. It's many people compare it to the appearance of the internet, and it's somehow like a new way of dealing the things, new way of operating, and it will come the new future for us. I took this standard definition of the property technology by using the information technology in general and all kind of this platform economics in real estate markets. And we can use all kind of these tools, but what's important for us when we're doing any business, including real estate markets, and especially real estate markets, because you're talking about long-term commitments, about transactions that are with higher amount, we need something that everybody needs around us. It's the trust. So far, all these monetary systems and legal system in the countries, they were created by the corresponding institutions that are guaranteeing the value of money, that are guaranteeing the value of the contracts, and the value of the documents that are issued for the property. and it's like worldwide consensus on how this is done. We can always say that we need these mechanisms to establish this so-called trust. So if you make a transaction in certain currency, then the currency value is guaranteed by the country, by the corresponding country, and the value of the contract of your ownership of the property is guaranteed by the legal system of that country. But you can always say, well, whenever we make these contracts, there is a big overhead. They're expensive because there are many middlemen in between the two parties who are exchanging the property and value and money. So these middlemen include notaries, lawyers, and other intermediaries, real estate agencies. So that means the price of the apartment is getting higher, the price of the property is getting higher, and you start asking yourself, is it necessary? Can we find some kind of other mechanism that will guarantee the trust by lowering the fees? So one potential is this new technology related to the blockchain. I would briefly remind about this evolution of the property technology, or so-called PropTech. At the beginning was just online listing sites. You are very comfortable sitting home and looking for your property from home, and then it's still quite popular. You are searching, and then whenever you get interested, you start saying, okay, this is a good for me, good location, good quality, I'm going to see this property in person. In some cases, maybe not, even not in person, and then you can do the transaction. The next generation, 2.0, is using a lot of data analytics and some kind of virtual reality or artificial intelligence to offer a little bit better specialized service. So like they are collecting your data, and then they start offering these tools. They're offering you your dream property, and then they say, okay, this is the list we made for you, and then they facilitate this choice, hopefully spending less time to choose it. And finally, now we are talking about the third generation, the experimentation with the so-called these emerging and disruptive technologies, in which we can use many of the new concepts, new tools that we have, very, very creative. Sometimes you can use new devices like the drones to present better the real estate in question. You can use plenty of these virtual reality tools that you can imagine you are entering the property and you're looking the details in a similar way as you would do it in person. And then, we are talking about these smart environments, ambient intelligent environments, smart cities, smart buildings, everything that is related to plenty of sensors, the so-called Internet of Things. And finally, this blockchain technology will facilitate plenty of the businesses around the real estate market and exchange. Speaking about PropTech, I took this, let's say, platforms and technologies proposed by Oxford University in the UK. And I was thinking about some of the IT things that I'm not going to read all of them, but what is interesting, what is motivating for us to think in the future and collaborating, people that are coming from the IT sector to people that are coming from civil engineering and real estate, how we can use all these new technologies, the big data that we have, the virtual and augmented reality, Internet of Things, artificial intelligence, and the disruptive blockchain technologies. Moreover, now we are in a very specific period, and everyone is worried about this pandemic related to COVID-19, and then, well, how this new way of living, how this operation in terms of real estate exchange will work in this case. So now we see we have plenty of tools. Today we are presenting, many of us are presenting online. And now can we do many things on distance, including the real estate exchange, by using the new technologies that will help us in choosing the real estate, in selling, in buying real estate property. The PropTech is related to many areas. Again, I'm giving this a big graph here and a big diagram. Many people think about this financial technology, so-called fintech. There are so many BizTech or business technology concepts that help the PropTech. Then the megatrends of globalization, urbanization, as the previous speaker said, everything is changing. It's changing so quickly, especially in populated countries like Russia or Vietnam. These cities are evolving on a daily basis. We are talking about the smart cities. The population is growing. We have to think about the energy efficiencies. And again, I mentioned this Internet of Things, where we want to put plenty of connected devices. When we say things, we mean little sensors, little devices, our smartphones, but also some bigger devices like the intelligent vehicles and flying objects. So we are very general there. Security, cyber security is one big issue there that we have to still work on that. And then I'm not an expert in the construction technology, the so-called contact, still talking about the smart environment, smart homes, a lot of automation there related to alternative building materials, and then how to design and build the property in the future. A quick jump to this shared economy, in which we really want to do the transaction peer-to-peer. Why do we need the middleman? Why do we need the third party to increase the price? So if we do it in a peer-to-peer, if we increase the trust, maybe we find some enablers like the blockchain technology to increase the trust. Maybe we can find a lot of new business model and a lot of improvement in the asset utilization and optimization. And finally, the most important is the information technology, infotech, where we really talk recently about all these new concepts like the machine learning, big data, deep learning, how to do the automatic recognition and treatment of the data, including algorithms, artificial intelligence, augmented reality, virtual reality, etc. A lot of applications that facilitate us our life, and our important focus for this talk is this blockchain technology and the so-called smart contracts. I will explain what is that. PropTech today is becoming very important. It's in 50 plus countries. They created their national communities. Like many countries, maybe I missed some of them. I mentioned a couple of examples, like in Russia, Austria, Belgium, Switzerland, etc. Also some regional initiatives, like in the Baltic area, in the Nordic countries, and they are accepting it as a new necessity, as new way of operating. This is some prediction of Cisco that the blockchain market will grow. So there are some numbers. By next year, it will go in the range of $10 billion. And then by 2027, might be 10% of GDP will be will be doing transaction through the blockchain technologies. And then all this economy, so-called programmable economy, will deliver much more efficiencies, will create a lot of new innovation and businesses. And then the prediction by 2030 is by Cisco is estimated at 30 trillion. When we speak now about real estate chain, when you do a transaction, everyone is familiar. You have to transact your money to a trusted party, and then this trusted party has to check it with some institutions, and then this money is transferred to the final owner. This is at least a couple of steps, maybe even more. If you have intermediaries, when you want to buy apartment, someone is searching for you. When you want to sell apartment, someone is listing your apartment. And then once everything is done, the property is transferred. So it's getting quite long, complicated, and most importantly, expensive, because all these middlemen, not only they take part of the fees of the final price for the real estate, but also they take a large amount of fees. So they're quite expensive, in the range of various regulations, but sometimes it's in the range between 5 and 10%, which is a lot for such big transactions. And then unless you are not a very rich person, that will easily overcome some hurdles like international bank accounts, you have a nice credit score, then plenty of these managing funds, accreditations, so you are willing to pay, then it's very hard for regular people to do these transactions for many reasons. Sometimes even if they want to do it, they spend their savings on unnecessary third parties. They are not allowed to do. In a lot of cases, there is very little transparency. Sometimes we talk about tax evasion, corruption, money laundering by doing these transactions. So there's still plenty of negative things related to real estate, and many of the countries they struggle to limit this and to fight against it. As I mentioned, these fees for the middleman are getting huge, and they are even growing. And then for regular people, this globalization is not easy to overcome. And then, well, liquidity as a definition is how easily this can be cashed. So it's another obstacle, like you are buying something, then you want to sell it. So it's again a lot of overhead fees, etc. So how to solve these problems? So this is the blockchain, same scenario, how we want to do the transaction. It's as simple as just making something called smart contract, and then the property is transferred by one click, and then in few minutes the cryptocurrency or any other way of payment token is transferred to the other party, and the ownership is recorded in this growing database called blockchain, and nobody can change it. So it's as simple, it's almost like utopistic, but there are plenty of procedures behind it to guarantee this way of transaction. So we managed to overcome this hungry middlemen in the middle that are charging a lot of transaction fees, and we will pay some transaction fee, but it will be very, very modest. It will be maybe in the range less than 1% or even less than 1 per mil. So now we said that we use this global distributed database called blockchain, and in addition to guaranteeing us some level of trust that everyone in the network is confirming the transaction and nobody can cheat on the transaction, neither for the contract or the property deed or on the payment. We also have a very nice feature about this database that is protected from cyber attacks in a very nice way. It's protected by design. The security of the database is guaranteed by the peer-to-peer structure of the network. So there is no central server. So if you have the network that consists of tens of thousands of nodes, almost equal, let's say in their rights, if someone wants to attack such a network, you don't know who to attack. You have to shut down everyone, and that's quite difficult or even impossible. So that's one advantage. Another advantage is that when you create this database, every block is related to the previous block in a way that they are protected with a cryptographic hash that is impossible to change. If you change even a single dot or a single space in the record, in the contract, then you will change the whole structure of the database because they are related. And this cryptographic hash is a fundamental to establish this level of trust in the so-called linked blocks database. And then whatever happens suspicious, it will be immediately detected, not by one, not by two people, but by the whole community. So somehow the whole community is protecting the network. So that's why this blockchain is quite promising, not only for the real estate, but for many other operations. So again, blockchain is a protocol distributed database that is proof security secure by design, and it allows to record some important information in a distributed way. So if some information is lost in one node, it will be stored in another node. So as I said, you cannot shut down all 10,000 or 20,000 nodes. And then again, moreover, nobody can change unilaterally a block, even if everyone agrees. It will be impossible to change because it once recorded, you have to destroy everything to change even a single bit of information in the blocks. So as I say, you cannot do any modification, you cannot delete information, you cannot alter information, you cannot rewrite contract or payment. You cannot do any way of manipulation, legal or illegal. So it's not possible. And that's secures this level of trust that I mentioned at the beginning. So once you have this database, it increases the security, it increases the transparency. So everything is well done in a transparent way. So if someone wants to do audit on the transaction, it's there, they can do it. All the institutions, the police, law enforcement, everyone who wants to check about the transaction, they can go and check it. Very hard to do illegal activities. So it's not like Bitcoin is related to the dark web, etc. No, it's very, very transparent, accessible, and very reliable. So all these four aspects are necessary to build the trust, and there are no middlemen. We are receiving this almost for free because the transaction cost is very similar to transaction cost of any amount of money, even if you want to transfer $100. What is interesting that All this, as I mentioned, these transaction costs are, well, almost quite low and almost equal. It depends if you want a faster transaction, maybe you can offer a little bit more money for the transaction and it will be done in a fast way. All this transparency can allow immediate checkup upon your identity and credibility, your credit scores, the capacity of payment, and then there is no way to manipulate. I mentioned, again, I will repeat so many times, but that's really, really quite important. The middleman fee is cut. No need to be frustrated that you paid so much money for people who barely did something and they make their live off out of nothing. We will get into fight with this community, but many smart people from this community are realizing the new reality, and then they start orienting themselves in helping this new way of doing the business. And then, very important, the complete transparency. Many people can ask about privacy. Yes, there is a way to make some permission blockchain in which certain group of people can have access. And of course, the institutions can always have access to check upon the legality of all this.
Oh, excuse my interrupting, Yaroslav. We're running out of time. 1 minute left, please.
Oh, yeah, thank you very much for reminding me.
Yeah, sorry about that.
I'm approaching the end, so a key point in this blockchain is so-called smart contracts. Smart contract is like a kind of computer program that just maps the a normal contract, and then it's a good for collaboration between legal people and IT people, how to make this in an automatic way. Here I have one example. Let's say Bob sends 20 Bitcoins to Alice to transfer. Alice has to transfer her ownership of the house to Bob for these 20 Bitcoins, which is approximately $200,000. And then all the community, once this contract is there, all the community update their database. It's already on the blockchain. And then we know that Bob has the house now, and Alice has 20 Bitcoins more on her account. And then this record is recorded in the so-called blockchain, and so on, and it cannot be anymore modified. There are some limitations. Still a new technology. People don't have enough trust. The transaction time on some of the blockchain, like the Bitcoin blockchain, is like 10 minutes per block on average, a bit faster for some other blockchains like the Ethereum, which is meant for this smart contract. There is limited availability and scalability at the time being. And then there is limited ability to have interface with the real world information that will be overcome in the time to come. The volatility of the cryptocurrency is still kind of an issue, but the time is coming where everything will be solved and more stable cryptocurrencies come. And then plenty of the countries are getting ready for the getting ready legally. Many of them are doing quite well, like Switzerland or Cyprus or Malta. Belarus is not bad in these legal frameworks for the blockchain, and Estonia. So we know many countries in the Asia as well: Singapore, Korea, Japan, and then yeah. Thank you very much. Come за дню. Большое спасибо.
Thank you, Ninoslav. Thank you. We unfortunately don't have time for questions and any possible answers in this case. So we need to proceed to the next speaker. Thank you, Ninoslav.
Thank you very much.
So I see that so Professor Anatoly Borodinets joined us recently. So I'd like to present his report. He's Doctor of Sciences, Professor, Head of Department of Heat Engineering and Technology from Riga Technical University, Latvia. And his topic is Modern Energy Efficient House. So Professor, if you're ready, please join us. Thank you.
Okay, hello, I'm here. So just a second, let me to share my screen, but I cannot share screen right now. You need to remove the previous presentation.
Okay, Nina, could you please stop sharing the presentation because we cannot proceed with the next.
Okay, excellent. Yeah, excellent. Now I am ready to share my screen right now. And here it comes. So, can you see it?
Yes, we can see well.
Yeah, but I can switch. How can I switch the slides?
No, please share not PowerPoint, but share your screen.
Share screen. Oh, okay. Yeah. Okay, so where is the share screen? Okay. Oh. There you go.
Not only PowerPoint window, but full screen.
I'm trying to remove. I don't see the button now. How can I remove the?
So it's supposed to be green button. Demonstrate.
I know. Yep. Stop share. Okay. Yeah. The share screen. I have two screens. That is why I have a problem right now. So.
It's okay. Now we see you well.
But I am not able to switch the slides.
Press and F5.
Yeah.
Нажмите F5.
Я понимаю, просто никакой реакции нет. I understand very well. Let me close it. But I have some issue with the laptop. What? Okay, let's stop share. Не реагирую. We have some problem. Some is PowerPoint, and now we will restart the PowerPoint, and I think the presentation will be launched. So, sorry for the delay. I have a new computer right now, so now it should be fine. I hope so. Wow. So I use it today another laptop, so that is why I have some technical delay.
So Anatoly, would you like to give a turn to the next speaker? Then we'll go back to you if you don't mind. Okay. So we can. Oh no, that's fine now. Okay, I think it's so fine. Thank you. It's all fine, but your microphone, switch on the microphone, please.
Okay, now. And now, finally, can you see me and can you hear me?
Yes, it's all perfect.
Okay, thank you. Sorry for the delay. I'm very glad to be here in such a conference. Of course, it would be more nice to visit Vietnam in face-to-face conference, but I hope that it could be done in next year. And I have some delay today with my staff, and now I am here finishing all my stuff, and would like to make my short presentation on the modern energy efficient houses. So nowadays we are facing a lot of problems in terms of global warming, limited access to energy resources, and problems with fossil fuels and indoor climate. So for a while, something like 300-400 years ago, we don't have any central energy supply and energy production. We have to use some limited energy sources, local energy sources like fire and so on. But anyway, we are trying to keeping our internal conditions at an acceptable level. So we are trying to manage ventilation, to manage flue exhaust and so on, to ensure the thermal comfort in our houses. So we were really relying on energy form and optimal design in terms of heating, cooling, and ventilation. Later on, we have some development. We have a new central heating sources. We have district heating, grid electricity. So we were able to build the new houses where we have a larger proportion of window. We have a higher ceiling, so it's not like a 2 meters, 2.6 meters, but it was like for the 3 and 4 meters high floor ceiling. Afterwards, we were able to build the new skyscrapers and the extreme large glazing area. And now all this stuff lead us to extreme energy consumption. So the modern building consumes a lot of energy for the heating and for the cooling. So I am coming from Latvia, where we have a heating dominated country, and we have a cooling and slightly, we have a heating and slightly cooling. For Vietnam, I think that the more actual issue is overheating during the year. And there is some funny picture where you can see some progress for human development. We're ending in such a position as we started, but of course it's just a funny. I'm not sure that it was in reality. And the same problem now with the houses is for. I use my laser. If for the 300-400 years ago we were relying on form, now actually we are coming to such a form as well. So we are not constructing anymore such buildings with extremely large glazed area with such extreme high ceiling. So we're trying to make it more compact, to minimize glazing area, and to put also in use the solar energy in terms of passive and active way. So that is what we are here. We're trying to build almost the same buildings as it was a time ago. So if you take a look on the energy consumption, for example, in case of Latvia, and I think it's very similar for all Soviet countries, we're all former Soviet countries, yes, where all the buildings were built according to the typical project without any thermal insulation due to some circumstances. And the energy consumption for the space heating and hot water approximately varies from 200 to 350 according to the building technical conditions. And after 90s, we have a new regulation, more like on European regulation, and taking into account their devices. We were working on the reduction of maximum possible energy consumption for the building. And as you can see, like building built in between 2014 and 2019 consumes for the heating not more than 90 kilowatt hours per square meter. Nowadays, there should be 2019. So the maximal allowed heating load is 60 kilowatt hours per square meter, and for the new tendencies for the passive houses nowadays it's like a 10-15. Of course, for the Latvian conditions, it isn't really realistic what we can get this value, but we are trying to put the new technologies, a new design approach, new maintenance of the building to reach such values. So anyway, the idea is so that any building, is it passive or energy efficient or simple building, it consumes the energy, and we need to produce this energy in most efficient way. And the European trend, and is for Latvia as well. So what we need to build starting from 2021 is a nearly zero energy buildings. So it's our main target. So we are trying to develop and to promote new technologies, new insulation materials, to reach such a number. And this per hour for cold climate, the value is 40 kilowatt hours per square meter. So if we are able to build in houses at 40 kilowatt hours per square meter, also we can be assured that we can reach nearly zero energy buildings. So the value 40 kilowatt hours per square meter is pretty similar across the Europe, except maybe some warmer climates or colder climates. But here in Baltics, it's 40-45 kilowatt hours per square meter. It could be like a main target value to fulfill the requirements. But not only the heat consumption for heating should be fulfilled, we need to focus also on the primary energy consumption. So primary energy consumption, also all the energy what should be produced before the converting. So, and it takes into account not only heating, but also hot water, mechanical ventilation, and other things. And all the primary energy for our buildings, if they're willing to get this nearly zero energy building status, should consume no more than 95 kilowatt hours per square meter as primary energy for whole systems. And actually, the mechanical ventilation with heat recovery is a must for such a building. So it's, at least the 75% efficiency should be achieved for such mechanical ventilation systems. And also another mandatory thing is use of renewable energy, on-site renewable energy. So we need to install local PV panels or solar panels. Of course, the wind energy could be used as well for such houses, but it's not realistic and not feasible that we can use it within the city in dense areas. So maybe some for rural farms, this could be an issue. So these are the main parameters if you would like to build these nearly energies in the buildings. And as we can see, in average, typical Latvian building stock, I think not only Latvian but Baltic and as well as Russian and other countries in cold climate consumes more than 200. So we need to achieve such a significant reduction from 200 to 200 kilowatt hours per square meter to 400 kilowatt hours per square meter. So this means huge changes in design, construction, and maintenance of the building. So, and it's very hard task to get together all these involved parties like architects, house owner, builder, and later on the maintenance company. So there are 4 persons which are directly responsible for such a number. Architect can design extremely efficient houses, but construction quality can significantly decrease, and afterwards the maintenance could be a very inefficient way. Of course, if we speak about the insulation, about this retrofitting, about the energy efficiency, always the first thing comes into account is heat transfer. So actually insulation of external envelope. So when we in Latvia just started to thinking about this energy efficiency, we started to insulate the building. So only the wrap of the building envelope into insulation material. So, but actually here we have some limitation. If this thermal insulation before the renovation of existing multi-apartment buildings built before 90s, it varies approximately 1 watt per square meter. Nowadays, after the thermal insulation and as well for the construction of new buildings, it should reach the 0.15 and 0.1 maybe for the passive houses. The lower values actually theoretically is possible, but in practice it's not realistic to have the U value, so heat transfer coefficient lower than 0.1 watt per square meter. So actually there was a first thing in Europe in the 70s and Latvia in the 90s which was first taking into account the thermal insulation. But what we can see that regular thermal insulation can reduce energy consumption by 40%. So from 200, so approximately from 230, 140 to 75, 80% per kilowatt hour per square meter. So it's a twice larger, twice bigger than required by nearly zero energy houses. So there is some study was done by me and my colleague, former PhD student Alexander Zayats, where we have analyzed renovated building stock, and as you can see, 40%. But the problem is, what in Latvia in 2007, 2009, we have started only with the thermal insulation of the building, and it's now it makes a huge problem because not the ventilation, not any heating system was addressed at that time. So only thermal reduction. So the ventilation wasn't retrofitted, and now we have a lot of problems with CO2 emissions inside the buildings, CO2 concentration with moisture and mold and so on. But also reduction isn't such a big that is required by modern legislation. So actually, why we need this energy consumption for the building? So before 90s, the very simple approach was taken for the design of such a building. Just some main parameters as a design heating temperature, design cooling temperature was taken into account to size this system. So no any respect to indoor heat gains, solar gains was taken into account. Later we have started we have taken into consideration, we have started to take into consideration that as a human who is inside the building. We were starting to think about their thermal comfort, about not only temperature relative humidity, but about the temperature asymmetry, about the ventilation CO2. Nowadays it's VOC as well. And after all the buildings, so where retrofitting, we have faced the problem with the moisture content, so only insulation wasn't a problem. Else in case if the buildings were not insulated or not insulated, nowadays we have a significant discomfort for such a human being, humans inside the building. Nowadays also we are not treating the building itself. Now we're taking into account the people who stays inside the building. Now we're trying to understand how the building communicates with the infrastructure. So how the on-site produced energy, renewable energy, can be used for other purposes. For example, to use produced electricity to charge the electric cars, or how to efficiently use electric cars. Or maybe such a building should be also located close to the public transport. So no, it's not possible nowadays to state that we have the energy efficient house, which is located somewhere far away, where you need to use the diesel car to get in your work. But if your house is close to the bus stop, it also makes more environmental friendly. And nowadays we are not able to treat the buildings without this waste management. So we need to separate the waste, which is now anywhere across the world. So in Russia, in Latvia, everywhere, and for sure in Vietnam as well. So nowadays, energy consumption, not only for the heating, for the cooling, it's energy consumption for management of local systems, for cars, for the electric cars, for LPG cars, for public transportation, for wastewater. So now the energy efficient buildings are much more complicated, and it's coming out of the box, out of this building envelope. So the solar energy here, and also now later, so what we have done, our study, buildings interacts between themselves. So we are using some smart distinct grid, which is able to produce thermal energy and electrical energy. So buildings can exchange. For example, if the south-orientated facade can produce more than north-orientated facade, so buildings can exchange and to sell to each other all the energy in the future, of course, now. And so now working on this issue. And also not always will we need centralized heat plant. So maybe just some nearly zero energy districts can be self-sufficient without external supply. And maybe in some rare cases when we have extreme cold conditions or other issues, where maybe we can use some extra power supplied from outside the district heating. So nowadays, so we are switching from single house to multi houses to the local small grid. So according to the European Union RIO approach, there is also boundary conditions for the buildings. What could be produced on site, what could be delivered from this outside boundary conditions. And of course, for the near zero energy building, we need to produce as much as possible on site. But the problem also is that sometimes we are overproducing, sometimes it's lower than needed. For example, in winter time, we are not able to produce sufficient amount of energy. In spring or summertime, we overproduce. So it means we need to go beyond our building and to exchange or to sell the energy into the local grid or to the central grid within the city. So it's a now challenge for the new design. So design new buildings, design of new districts. What it means for us, for engineers. For engineers, it means that we are not able to use any more simple energy calculations. So before, even 10 years ago, we were using just simple cooling degree days and heating degree days and heating cooling periods, length of the heating and cooling period. Nowadays, we should use more complicated softwares, dynamic energy softwares, which allows to calculate energy consumption of the building, taking into account the human behavior, climate change, what else? So all these dynamic energy prices and so on. So now we're not using the simple web-based or Excel-based calculation programs. So we are switching to dynamic energy simulations like IDICE, USCA, Comfort and Energy, and ISV, and so on. So there are a lot of tools, also DOE2, US open source engine. So there are a lot of possibilities. So for us, for engineers, so the energy calculations now is much more complicated, much more details, and require a lot of energy and inputs. So also before, when we did the calculations of regular buildings, which wasn't energy efficient, which energy consumption was more than 100 kilojoules per square meter, we were using steady state solution where the temperature was assumed 18 degrees Celsius or 20 degrees Celsius during the whole heating seasons. Now using the new softwares, new approaches, we can change the we can simulate, we can take into consideration human behavior. So when we are staying at home, that we are not at home. So it means we can reduce energy consumption for each day during the 365 days. So we can make the very detailed calculations and to propose better technical solution and better operation of the building. So when it makes sense to reduce the temperature or where it's better to keep a steady state solution. So also we can take nowadays into consideration all the human behavior. So what they're wearing, what kind of activities they're doing. So before, now actually we didn't take into consideration such things. So now also we can take into consideration what people can wear more warmer clothes or can do more extreme work during their stay in, for example, office building or some sport buildings. So nowadays, this is our reality to make it more and more detailed. And the next thing, besides this theoretical part, is the technology part. So we need to ensure technology is cheap. So nowadays, here in Latvia, in Baltics, as well as former Soviet countries, the oversized system are used. In our case, I would like to speak maybe more about the district heating system. So the district heating system was designed in the 60s, 70s with the operating temperatures more than 100, 120 degrees Celsius. Even now in some countries we can find in more than 120 degrees Celsius supply temperature. And nowadays, when the technology are changing, we are not relying anymore on gas burning turbines or on some coal-fired plants. So now we are trying to integrate all the renewable energy. So it could be centralized and decentralized systems. So we are trying to rely on renewable energy sources. We are trying to use wind energy, storage balance, and so on. And as you can imagine, the solar systems, other systems, for example, waste heat from these factories and from data centers could not reach 100, 120 degrees Celsius. And it means that we need to adapt our system for the new perspective. When all the buildings will be insulated, when the thermal panels will be installed, so we will have a lot of heat with a lower temperature. The 60 will be maximal if we are using the solar panels, and we are using thermal solar panels and using solar heat pumps, ground or air heat pumps. That means we need to change our system to such a thing, and it's a pretty challenge for us to manage and to retrofit district heating systems to ensure integration of different types of renewable energy sources or recovered energy sources. So actually, what we're speaking about, to lower temperature inside the system. And then now we are starting from first generation district heating system. Now we are operating the third generation system, district heating generation system, and coming to the fourth and even fifth generation of district heating system. And it's make a problem. So why we need to reduce temperature? We need to reduce temperature, first of all, because the buildings are renovated and insulated, and we have a lot of different other sources. And there are a lot of different examples you can find on the internet, and where we are using the central heating systems where we have a temperature 70, 40, and 40, 20 degrees Celsius, so extremely low temperature. So it means we don't need any more gas turbines. We can try to ensure a sufficient heat supply with some minor energy sources. There are a lot of such examples across Europe. There is only one from Stuttgart, and I think you can find more. And also for Riga, for some local district, we have developed different scenarios how we can reduce energy consumption to improve overall energy efficiency and to reduce the CO2 emissions. So we have tried to analyze how the buildings will be renovated. In Latvia, we have only 5% of the multi-apartment building renovated by now. But in future, we need to renovate, so 95% more. And in the case of how fast, how efficient will be the retrofitting, also we can see the changes in the district heating system. There are different scenarios when we have fully renovated distribution network. We have only a few % of year of building stocks renovated, and also all these things should come together. We are not able only to retrofit the buildings without the respect to existing grid, so we need to retrofit it in a balanced way. And if we can ensure this balanced, sustainable approach for whole district, so as I told you before, to come out of this building envelope and to take a look on the holistic approach, we can reduce energy consumption for the buildings as well as energy consumption, energy losses in the district heating systems under different scenario. Maybe I'm not going to take a look closer on these details, but you can read it later in the presentation or in an article later on. So this our approach, so we can sufficiently reduce whole system. So maybe the buildings, retrofitting of the buildings wouldn't be such efficient, but in an optimal way, combining efficiency in distribution network and buildings, we can get it more efficient. Also for us, I don't know, I think it's not only for us, for Europe, for Latvia, but for whole Europe, it's very actual to reduce emission of greenhouses. So, and it's, for example, CO2 by the sustainable management of districts, we can reduce by 41% by optimal optimization of retrofitting and renovation of district grid. And also by increasing of renewable, minimizing temperature inside the systems, we can significantly increase use of renewable energy sources like I told you before, solar and heat pumps. So I have like 5 minutes more. And yeah, for this
you have about 4 minutes, okay?
4 minutes, yeah, I'm just close to the end of my presentation. Thank you for, and as we can see, there also by combining different means, not only in the building but in the system, we can reach more optimal use of fuel use, like by 95%, we can increase overall efficiency of the system. So we have a lower losses, better production, lower losses in gas boiler houses and so on. So it's very important now for us to make this design approach. But last thing what I would like to mention before the end of my presentation, the problem is in our model that, for example, there is example of the Stuttgart, but for that it's hardly possible to reach that all buildings will be renovated, and always some of the buildings will be not renovated, so due to some circumstances, financial, technical, and so on. And the problem of how these buildings could be supplied by low temperature systems. So if there could be 2 or 3 buildings, and later in my presentation you can see that due to the fact that all Soviet buildings, so heating system of all Soviet buildings were oversized and slightly overestimated, it can ensure that even after the temperature will be reduced in the district heating system, such non-renovated buildings could maintain most of very optimal temperatures. In some cases, it will drop. I will skip some slides due to the time limits, and could drop until the 18 degrees Celsius, but it's only in rare cases when we have strong wind, outdoor temperature minus 20 degrees Celsius. In that days, of course, non-retrofitted building could suffer from the inadequate heat supply, but in other days, the systems are sufficiently oversized to ensure this. So in that case, non-retrofitted buildings should use sometimes extra electrical heat or local heat pumps or split systems, so-called. And yeah, this is was an issue for those who that now all these buildings is possible to renovate. So there are some big comparison of different district heating systems. So in the case where you have a low district heating system, non-renovated building, during the year, somewhere in February, would reach some discomfort, but not for the long time, only for the few hours a day, we can observe such a temperatures. So and to conclude, just I would like to say that now we as HVAC engineers or sustainable building engineers are responsible not only for the single cases, but for the integration of many parameters into one system. So buildings, inhabitants, energy supply, maintenance, and of course weather conditions. And thank you very much for your attention. And yeah, I have to apologize for some delay during my presentation. So thank you very much.
Thank you very much, Anatoly. So unfortunately, we don't have any time for questions and answers left.
Okay, but yeah, I am here online now. It's very easy to reach me anytime.
Yeah,
thank you for your patience. Okay, bye.
Okay, so we proceed. Would you please stop sharing the screen as well? Yeah, we'll proceed to the next speaker. So we are going to transfer back to Moscow. So the next speaker is Professor Armen Martirosyan, Doctor of Sciences, Department of Soil Mechanics and Geotechnics, the Moscow State University of Civil Engineering, where we are at the moment. And the topic of his speech is calculation of pile foundation settlement, taking into account the influence of soil liquefaction. So, Professor, if you are ready, please join us now. Okay, sorry, we have some problem with the connection. We'll proceed to the next speaker. So, when we'll go back to Professor Martirosyan later on. So, Borislav, are you ready? Can you hear me? Borislav Christoph from Germany at the moment.
Yes, I can hear you.
Yeah. Okay, I will announce you, don't worry. So we are going to Germany at the moment, to Berlin. Doctor of Engineering, Professor, Department of Engineering Sciences, Transportation, University of Applied Science in Berlin, Germany. And the topic of his presentation is determination of the existing site distance and its influence on the speed on highways. Thank you, Borislav. Please join in.
Yes, please run the video I've sent because...
Ladies and gentlemen, it's a real honor for me to be a keynote speaker at the conference FORM-2020 in Hanoi. My name is Borislav Christoph and I am a professor in transportation engineering at the University of Applied Sciences in Berlin, Germany. The topic I'm going to talk about is the determination of the existing site distance and its influence on the speed on highways. The main task of a high-quality road design is to provide the driver with a clear information about the course of the road at an early stage. According to the Road Traffic Act in Germany, drivers have to adjust their speed according to the existing site distance conditions. Therefore, the site distance is an important design parameter which has a significant impact on traffic safety, speed behavior, and driving comfort. The purpose of the stopping site distance is to enable the driver to stop in time in front of an unexpected obstacle with a certain height on the road or in front of the end of a traffic jam. In addition, as a regulating element in road design, it is intended to ensure early driver information and orientation. The driver reacts to external influences by choosing the speed and changing it. Therefore, the speed parameter itself represents the best and most suitable evaluation criterion for the driving behavior. Driving behavior can be understood as a uniform multi-layered control system, which in road traffic is referred to as driver-vehicle-road. This system is to be understood as an ordered classification of influencing variables on the driving behavior. The driver reacts to external influences by choosing the speed and changing it through deceleration and acceleration. Traffic conditions, the condition and the design of the road and the environment, the vehicle with its technical data and behavior, and the weather conditions have an influence on the driver and determine his driving behavior. The lateral side distance along curves can be determined graphically as an envelope curve from beams between eye points and target points. Each line's length is the calculated relevant stopping side distance. The eye and target point heights are both 1 meter on highways and lie in the axis of the own lane. The target point height is set for the recognizability of a vehicle at the end of a traffic jam. This method was developed by Schoss in 1966 to determine the existing side distance, which is called the visual field method. In this method, a line with a required minimum stopping side distance length is stretched at regular intervals and thus enables the calculation of the required lateral visual field in the layout plan. It becomes clear that the effort required to implement this method by hand is considerable. That's why, in 1999, the side beam method was further developed into the side cone method, which works completely spatially. Its accuracy depends mainly on the density of the cross-section profiles and the level of detail of its processing with regard to the terrain modeling. The side rays from a point of view to all target points are combined as side cones. In the mathematical sense, this spatial cone has no circular vertical intersection surfaces and does not have to be closed. With this method, not only individual side rays are considered, but also the entirety of such spatial cones of side generated from standpoints. The calculation of the existing side distance is possible with CAD programs directly during the design. The prerequisite for this is a sufficiently accurate digital terrain model of the entire traffic facility and the terrain with all possible obstacles reducing the side distance. The required stopping side distance, according to the German design guidelines for highways, is the distance required by a driver driving with the recommended speed to stop in front of the end of a traffic jam on a wet road. Thus, it corresponds to the stopping side distance of a freely moving vehicle and is composed of the distance during the reaction and impact duration, which is this one, the blue, and the braking distance, which is the red section. The transmittable braking deceleration is assumed to be constant at 3.7 meters per square second, which is braking without an ABS system. The average reaction and impact time in this model is 2 seconds. Now I want to tell you something about the route selection and the determination of the existing side distance. The A72 federal highway between the cities Hof and Chemnitz, which is one of the oldest highways in Germany, was chosen for this study. In the 1930s, the A72 was originally planned as a corner connection of the basic network routes Berlin, Nuremberg, and Berlin and Frankfurt-Dresden. The A72 was rebuilt between 1990 and 1995 with the axis and gradients closely following the original planning of the 1930s. Such upgrading of existing highways with a near existing route, improved gradients, and improved cross-sections can lead to inconsistencies in the spatial alignment. In particular, insufficient side distances, discontinuities, and a danger of misinterpretation of the spatial elements can occur. The existing side distance was determined with the road design program card 1, which you can see in the right corner in the picture. The eye point and the target point heights were set at 1 meter. The figure shows an example of the sight distance in a left curve with a radius of 1000 meter on a 6-lane highway cross-section and a constant longitudinal inclination of 4.9% from an eye point in the left lane. Graphic sight distance bands were created for the whole route in both directions. The calculated existing sight distance was divided into classes of equal width of 50 meters. As the resolution of the human eye is limited and unmovable objects can be perceived at a distance of maximum 500 meters, the calculated sight distance was limited at 500 meters, and the following 6 classes were defined. You can see class 1 with an existing sight distance below 250 meters up to class 6, where the existing sight distance is between 450 and 500 meters. The statistical value for a speed oriented to the driving behavior is the 85 percentile speed, V85. This is the speed which is not exceeded by 85% of the vehicles driving unhindered on a wet, clean road. The statistical value for slow vehicles is V15. In this method, a randomly selected vehicle was pursued along the entire route by a test person with the measuring vehicle. The random selection allows for a representative image of the total collective of vehicles. In order to exclude any influence on the speed choice, it is assumed that a time gap is maintained between the measuring and the tracked vehicle. A time gap of 3 to 4 seconds to the vehicle in front has proven to be favorable on highways. 12 measurements were carried out on the entire route. In total, the speeds from the pursuit runs were recorded over a length of 1,344 kilometers. The records from the pursuit runs were used to create speed profiles for each run over the course of the route. Subsequently, the 15, the 50, and the 85 percentile speeds were calculated and plotted. In order to check whether the speed distribution of the relatively small collective of pursuit drives fit into the distribution of speeds of a larger collective, cross-sectional measurements should be carried out at selected points on the highway for comparison. The speed behavior of free-moving vehicles were recorded with a cross-sectional measurements at several fixed stations and could therefore be recorded on a much broader statistical basis and with less effort than with pursuit runs. The only possibility for the cross-sectional measurements were the bridge structures over the highway. In the present study, the speeds of approximately 150 vehicles per measuring point were recorded at 3 measurement cross-sections, which was considered sufficient for the statistical verification of the speeds measured by the pursuit runs. The Wilcoxon test for paired samples was selected to compare the speed distributions from the 2 measurement methods. All local comparison showed no significant differences between the speed distributions at the 3 measurement cross-sections in both directions. Here I would like to show you the results of the sight distance calculation. It is clear from the literature that the effective relevant existing range of vision on rural roads for the orientation of the driver is a maximum of 300 to 350 meters. On highways, however, there are significantly larger existing sight distance ranges, and because of the high speed level, larger required stopping sight distance ranges are calculated accordingly. Existing sight distances of up to 5,000 meters were often calculated. However, Side distances of this magnitude should not be considered relevant for perception and information reception in road traffic and does not influence driving behavior in any way. This limit, which corresponds to the greatest distance at which stationary objects can be perceived, is 500 meters as stated above. The figure shows an example of a side distance band. The curvature is shown with the red line. The blue line shows the existing side distance. The light blue line shows the required side distance, and the green line shows the gradient. You can see it above. It can be seen that even on highways, there are many sections where the existing side distance is below the required stopping side distance, like these sections. Notice that the required side distance never reaches 200 meters as the existing side distance does. These sections are potentially dangerous with their limited side distance. The speed profiles for each individual trip in each direction were determined from the recordings made during the pursuit runs over the course of the route. Subsequently, the percentile speeds V85, V50, and V15 were calculated. In addition, the speed differences between the speeds V85 and V15 were shown. The profiles were very detailed as the speed values were available every 2 meters. Here you can see the speed profiles with the red, blue, and yellow line for a section with a speed limit of 130 kilometers. The red line is the V85, the blue line, the V50, and the yellow V15. It is clear that due to the speed limit of 130 kilometers per hour in this section between the two cities Pirk and Plauen-Zuid, the level of V85 remains relatively constant. The V85 speed profile shows that the permissible speed is exceeded by 4 kilometers per hour on average, which is very less. The average difference is 17.6 kilometers per hour. The maximum difference between the 85 and 15 percentile speed is 28.7 kilometers per hour, and the minimum speed difference is 7.7 kilometers per hour. You can see it here. In contrast, the speed level in the section between the cities Troen and Reichenbach, on which there is no speed limit, is significantly higher. You can see it here. Although this section contains curves with relatively small radii, the V85 speed even reaches 180 kilometers per hour. The differences between the slow and fast driving vehicles are twice higher than on the section with speed limit. Excuse me. The average speed difference between the speeds V85 and V15 is 33 kilometers per hour. Over the entire section, the minimum value is 17.8 kilometers per hour, and the maximum difference is 55.7 kilometers per hour, which is much higher than the maximum difference of 28.7 kilometers per hour in the section with a speed limit of 130 kilometers per hour. You can see the average speed of the V85 and the V15 profiles in the different side distance classes. As expected, the existing side distance has an influence on both speeds V85 and V15. With increasing side distance, a clear increase in speed could be determined. At a side distance of less than 250 meters, the average speed of V85 is 144.4 kilometers per hour. And up to a side distance of 400 meters, it increases constantly. The speed V85 is 10.5 kilometers per hour, which is 7.2% higher in the last class compared to the one at a limited side distance under 250 meters. At a side distance over 450 meters, the V85 speed remained almost unchanged compared to the side distance of 400 meters, and no trend of increasing speed could be stated. For this reason, all side distance ranges greater than 400 meters were combined in the last class 5, and class 6 was removed, as you can see here. So there was no difference in the V85 after this side distance of 400 meters. An increase in the speed V15 was only noticeable up to a side distance of 350 to 400 meters. Therefore, side distances greater than 350 meters have no influence on slow-moving vehicles. You can see here the V15 remains unchanged after 350 meters of side distance. Now I come to the conclusions. A methodology for assessment of the speed and the existing side distance on highways has been shown in this presentation. It has been found that the existing side distance has a clear influence on the speed on highways. It has been stated that an increase in the speed V15 was only noticeable up to a side distance of 350 meters, and side distances higher than 350 meters have no influence on slow-moving vehicles. With increasing side distance up to 400 meters, a constant increase in the 85 percentile speeds could be determined. At a side distance over 400 meters, the V85 speed remained unchanged. It is therefore recommended that city highways and all highways should be designed in a way to ensure a side distance of at least 400 meters in order to allow a constant traffic speed level and to increase traffic safety. Thank you very much for your kind attention.
Thank you, Borislav. It was very interesting and informative as usual. Unfortunately, yeah, we are running behind the schedule. We have no time for question and answer. I'm sorry about that, but you can do it in the course of the section, maybe. Yeah.
Yeah, it's
Thank
okay.
you. So, yeah, we are going back to the previous speaker, which was announced, and the connection was interrupted due to technical failures. Hi, Armen. So from Moscow. So already announced, but announced once again. There's no problem. So, Doctor of Sciences, Department of Soil Mechanics and Geotechnics, Moscow State University of Civil Engineering, Professor Armen Termartirosyan. So you're welcome to start your report, please. Thank you.
Okay, thank you very much. And I'll try to show my screen to start my report. Okay, here is it. And so here you can see my presentation. My report theme is a calculation of the pile foundation settlement, taking into account influence of soil compression. This investigation was made with my master degree student, Ledik An. I'm sorry if I have some spell problems, but I called him just An. And I hope we will continue this investigation when we came back to Moscow. As now he will be not a master degree student and he will be a PhD student. So here you will see only the small part of our investigation, because we have a time limits, and in proceedings we have also the limits for article. But I try to present as much as I can. Okay, so let's start. Let me start from the introduction. A couple words about earthquakes. We know that earthquakes is well known as one of the cases of the worst damage of buildings and structures. But what is happening in the soil when the earthquake is going on? So one of the problems is liquefaction, and it caused from the increasing of the pore pressure. And here you can see the schemes of increasing of pore pressure due to soil liquefaction. So it increases, and the contact between the parts of the soil going on, and there is no contacts, and the pore pressure goes up, and that's the main case of liquefaction. So here you can see, it's also well known things that two figures, the biking instability of the pile and the bearing failure of the pile in the liquefied sand soils, or clay soils is the same. And here you can see the two figures. It's a bearing failure of the group of piles due to soil liquefaction. And here is the main hypothesis that we try to investigate. So the liquefied soil, after exposure to the seismic waves and liquefaction, pulls piles down, and additional downward load due to self-compaction of the soil layers have an effect on piles. So what I want to you to know in this hypothesis. So we all know that there is the depth of the soil that liquefied after or in the process of earthquake loads. And in calculation that is made now, there is no additional stresses or negative friction due to this soil is self-compacted after the earthquake. But we know that this process is going on. So, and in this self-compaction, it pulls the pile down. So we try to calculate the additional settlement after the earthquake, when the process of liquefaction is done, and how much will be this settlement. So how we try to calculate this this additional settlement. We try to here you will see only the calculation in Plexus. So it's a finite element modeling program. I hope all know this program and maybe calculate on it. So we try to calculate three cases. The first case is the pile foundation designed in normal geological engineering conditions. So there's no any seismic loads, nothing, just the static loads. The case number two is the pile foundation designed in seismic area, and there is no negative stresses due to self-compacting of the depth of the liquefied soils. And the case number three is the pile foundation is designed in seismic area, where the influence of soil liquefaction is taken into account. So we have additional stress on the pile skin, and it pulls down this pile, and we have an additional settlements. Here you can see we use the Russian standards, the Russian codes. It's SP24, and we use it to calculate the bearing capacity. And but in our investigation, we also use some codes from Vietnam, codes from European codes, German and Euro codes number 7, and also we use some American codes. They all nearly the same. So the main principle is the same. The bearing capacity is the divided into 2 parts: the bearing capacity of the bottom of the pile and the skin resistance. So here is all the same. That's why we take only the Russian one. And here is the recommendations when we designed some pile foundation for first limit of the bearing capacity when we design it in seismic area. So here is shown how to calculate the HD is the H of the liquefied soils, and we have to take their 0 skin resistance in this depth. So the skin resistance of the depth of the liquefied soils have to be taken 0. But there is nothing about to take in the settlement calculation the additional stress when the limit is going on the process of self-compacting. So let's go further. So here the case number 3, I already said that the bearing capacity is calculated by Russian standards, and here it's so you can see that it's done by FORM-2020, and here we try to calculate this this settlement. And how we do it? We have put in the program the volume strain of this depth of the liquefied soil, and here you will see how much we take in the program. So here is it, the volume strain on the axis in the Z direction was -1%. It's just taken for an example, 1% of volume strain, but we can calculate, or we can get it from the real investigation, real tests from laboratory tests. For example, in our laboratory, in our university, we have the reaction test machine where we can get the additional deformation after the seismic load, additional deformation of the soil. And so if we get the additional deformation of the soil, we can try to calculate how much is negative skin resistance that pulls pile down. Here is the seam on the figure 6, the piles, the diameter of the pile, the length, so it's 1.5 meter. The diameter of the pile, the length is 33 meters, and the thickness of the cap is 2 meters, and the load, distributed load on the top is 150 kilonewton on the square meter, and the magnitude of the seismic load is 8. Here you can see the very simple model. So on the figure 7 is design seam of the pile foundation, and design seam on the figure 8 is on Plexis 3D software. So it's very simple, but it's enough to just investigate the this hypothesis, how much will be the deformation of the top of this pile foundation. Here you also can see the material properties of the embedded beam. It's the pile in Plexis, and the properties of the slab pile cap, and the properties of the soil layer. So the properties is taken from the investigation that is made in Vietnam. And we used it for our calculations. And here is the results. The results of the deformation of the top is for case 1 is about 5 and 45 millimeter, and this is results for case 2, and this is results for case 3. And here is the graphs of 3 cases, the graphs of deformation from loads, and you can see that when we put the spin resistance 0 for the depth of liquefied soils, the settlement goes higher. And when we put the negative friction on the skin of the pile, or let's say the volume strain of this depth of the soil, we have also an additional deformation. And here it is the results of the numerical solution. So we have a 4 and 4 centimeter for case 1, for 12 and 3 centimeter for case 2, and 23 centimeter for case 3. So the difference between case 2 and case 3 is the deformation, additional deformation that we can get after the liquefaction of the soil. So using this method, we can calculate the deformations, the deformation of the settlement of the pile foundation after the earthquake. Is just one of the methods that we investigate in our work. So this is an additional part of my presentation, because I already said that we have limits in proceedings, and that's why we have cannot put all the parts of our work in this article. Now, here is the formula for calculating the settlement of the pile foundation, or even any foundation from the Russian standards. We also compare it with some standards from Eurocode and Vietnam and so on. They are very similar. So you can see that as it's a settlement, on the top we have sigma, and this is the stress. H is the height of the compressible depth of the soil, and E is modulus, deformation modulus. It's divided into 2 parts for deformation modulus of the soil in the first and second loading cycles. Here is on the figure 3, you can see the distribution scheme of vertical stresses according to SP 22. So it's the distribution scheme for the formula you see on the previous picture, and on figure 3 you see the scheme of theoretical calculation for deformation according to the suggested hypothesis. So we have the additional sigma q, that is additional stress due to the liquefaction of the depth of the liquefaction of this depth. So liquefied soils, some water saturated sand soils or clay soils or so on. And using this principle and these formulas, we also can calculate the settlement of the pile foundation after the liquefaction. It was done in our work in the book of master degree student, but it's you can see in the unfortunately in the article. And so what is the conclusions of this small report? So the settlement of the structures on pile foundation following earthquakes included soil liquefaction, is an important area of research. The paper presents a suggested hypothesis about the influence of soil liquefaction on pile foundation and their settlement after an earthquake. That the liquefied soil to the definite depth pulls the piles down due to self-compaction. The settlement in the foundation due to soil liquefaction based on the suggested hypothesis can significantly increase up to 87% in comparison to the convention calculations, and can be not within acceptable tolerance. The fewer researchers of liquefaction included settlement of pile foundation, including evidence of the accuracy of this suggested hypothesis, are one of the main tasks in the design of structures in seismic areas. And also its main tasks our investigation with these postgraduate students in future. And here is the last slide with my photo and my master degree student. Okay, so and that's all. Thank you very much.
Thank you, Professor. I don't see any question in the box, maybe in the audience in Vietnam. Oh. Okay, then thank you. We'll proceed to the next speaker.
Thank you very much.
Okay, so the next speaker of today's plenary session is Professor Sergei Kuznetsov, Doctor of Science. He's with us. Thank you. Good afternoon already. So Professor, leading scientist of Department of Waves Dynamics, Institute for Problems in Mechanics, Russia, and also he works in Moscow State University of Civil Engineering. Okay, so Professor, if you're ready, so we are ready to listen to you. Thank you.
Thank you very much. I'll start with the presentation. Yeah. Can you see it?
Yeah, we can see it clearly. Perfect.
Okay, thank you very much. The presentation is devoted to the joint project from Russian Federation and Taiwan on territorial methods for seismic protection. Among participants, there were Ishlinsky Institute for Problems in Mechanics, the Moscow State University of Civil Engineering, actually it is one of the host universities, the Institute for Problems in Mechanical Engineering that resides in St. Petersburg, and Institute of Earth Physics of Russian Academy of Science, that is Moscow University. A couple of words why Taiwan was chosen to be of the main participant of the project. The explanation is given in the next slide. That is the Taiwan Island here, and dots of different colors represent known earthquakes. Diameter of the of such dot shows intensity of the earthquake, and colors represent their depths. As you can see, most of the earthquakes shown in red are the so-called shallow earthquakes. Shallow means depth of the earthquake is about from 0 to 30, maybe 40 kilometers in depth. Other earthquakes are of greater depth, and there are also some regions where origin of the earthquake resides in mantle, about 200 or 300 kilometers. The seismic region in Taiwan could be classified as extremely dangerous. Moreover, beside earthquakes, there are a large number of seismic faults that are cracks elongated from one part to the other part of the island. Actually, depths of these faults can be several kilometers. Despite of high seismicity and presence of faults, Taiwan decided to create nuclear power plants. And actually now in operation, there are 4 nuclear power plants. One of these plants is shown here. Taiwanese engineers try to protect their plants from seismic waves. And during this project, we have got a lot of experience from Taiwanese engineers, and our experience I try to represent in this presentation. Seismic activity and earthquakes. That is the first part of the presentation. At first, I'll show what kind of waves can be generated during earthquakes. That is, suppose that is the origin. From origin in different directions, bulk waves start to propagate. Currently, there are 2 types of bulk waves that are known: P waves, primary waves. They come first, their speed is the greatest one among other types of waves. The other type of bulk waves are S waves or secondary waves. Their speed is second to P waves. These waves propagate along straight lines, but at the interfaces that correspond to different layers. At the interfaces, there can be reflections and refractions. And to the Earth's surface, the waves actually come almost orthogonally, both P and S waves. Considering P waves, the particles on the wave front move in the same direction as direction of propagation, and these are considered as not dangerous at all for ordinary buildings. While S waves have polarization, particle movement, orthogonal to direction of propagation, and that kind of waves can destroy almost everything if energy of these waves is sufficiently large. Along with P and S waves, there can be also surface seismic waves known as Rayleigh waves due to its originator, Lord Rayleigh. Sometimes Rayleigh waves are denoted as R waves. They start propagating at the epicenter, projection of the hypocenter or origin of the earthquake to the Earth's surface. From here, they start to propagate. Energy of Rayleigh waves is concentrated near the free surface. They attenuate rapidly with depths, actually exponentially attenuate with depths, and can destroy almost everything. We are lucky that they are not quite often, as tsunami waves in oceans arise not due to every earthquake, but they rise sometimes only. The same is with Rayleigh waves. That is a map of Earth's surface. Here you can see that Earth's surface is split into what is known tectonic plates. And on the boundaries of tectonic plates, most of earthquakes occur. Here, because of movement of tectonic plates, these black areas, these are boundaries between tectonic plates. Now, how to model propagation of seismic waves. We have different models, according to their scale. That is the smallest scale, the globe itself. We can launch the earthquake, and earthquake will produce seismic waves, and then the waves begin to propagate. So somewhere here, near North Pole, we launched the earthquake. It produces bulk waves, but they attenuate extremely rapidly. And along surface, relay waves start to propagate. And if earthquake is rather strong, these waves can even move along the free surface of the Earth. They can meet each other at the opposite side of the globe, and even still go around the globe once again. Experimental geophysics show a lot of examples of such events. We develop also intermediate model that is used for more detailed analysis of origins of earthquakes and what kind of waves are emanating from it. Again, we can start earthquake somewhere here and watch what is going on. Here at the epicenter, all deformations are extremely large, but afterwards, waves start to propagate and lose their energy. That was intermediate scale, and now what is much more important, small scale model. Here you see Earth's crust. That is a thin layer. Thin layer means depth of the Earth's crust is about from 14 kilometers. That is the thinnest part of the Earth's crust in Koilsky Peninsula, to 70 kilometers in depth in Himalayan region. But average, it is thought that the average depth is about 30 kilometers. And Earth's crust consists of 4 different layers. The upper layer, shown in yellow, is the so-called sedimental layer, actually soil. The other part, known as granite layer. Then very thin layer. Actually, it couldn't be even seen in this scale. That is called olivine layer. And beneath olivine layer, there is basalt layer. And basalt layer is connected to mantle. It is shown in red. So I launch earthquake and will watch polarization of the waves. Polarization will be associated with arrows. Polarization means direction of vibrations, directions of deflections when a wave propagates. You see, arrows are almost vertical. That corresponds to Rayleigh waves, and also an interesting observation concerns speed of propagation along several directions. You see that along several directions on the Earth, waves travel faster than in other directions. That is because here we placed invisible fault, a tiny crack along which waves start to propagate, and that is known from experimental geophysics. And now, seismic protection. How to get protected from seismic waves. The first slide shows unsuccessful example when part of the bridge was destroyed during earthquake in 1999, when seismic protection installed somewhere here on the support was not adequate for the intents of the earthquake. Another example is more successful. That is Rion anti-Rion bridge constructed in Karin's Gulf. It connects two parts of the edges of Karin Gulf. The Rion anti-Rion bridge was constructed, seismic protection of this bridge was constructed by French engineer Alain Piquer, who suggested a very unusual solution for seismic protection. But before considering that solutions, we should speak about hostile environment near the bridge. That map shows how many earthquakes occurred somewhere here near the Gulf. That white regions, white circles represent known recent earthquakes. Moreover, in the place where the ridge was constructed, somewhere here, there are at least two visible faults going almost parallel in that directions. And the Gulf itself has a lot of different faults here. The soil conditions are also extremely poor because for soil formation, what is known, it is most silt, partly sand. The depth of the Gulf here is also relatively large. The depth is about 70 to 80 meters. So it was not easy task to construct the seismic protection. What was suggested? He suggested reinforcement with piles. That is an example of the pile that is a huge tube, 2 meters in diameter, filled in with concrete. That was put for about 20 to 30 meters to that soil to reinforce it, but that is grillage support for the pylon. And you see that diameter of the pile field is much more than the diameter of the grillage. You may ask why. Piquer decided that if relay wave will travel and hit that pile field, maybe peripheral piles will be broken, but they will save the internal piles, maybe will be safe on the actions of seismic waves. That was the first suggestion. The other one was related to seismic pad made of calibrated stone. For the first time, he decided to separate bottom of the grillage here and upper end of piles. Between them, he put huge pad of about 3 meters in depth to dissipate energy of the waves. And we'll see now how the first idea works. That is the model of peripheral piles, and we'll see how that peripheral piles dissipate wave energy. So I launch seismic wave. Red means high amplitudes of vibrations. Waves start to propagate, and miracle, inside that region, vibrations are small enough to make work of the pylon and the bridge itself in safe conditions. So the first idea apparently works. The second idea is associated with that pad. It is shown here in white. That is pylon, and that part is known as grillage. I make two models. One is made of solid, stiff pad that is directly connected to piles and to grillage, as was done before by most projects. The left part relates to Piquer's idea. So I start here for the first time. I start waves. They come to the pylon, start to diffract inside the pylon, and the pylon start to vibrate. Vibrations are extremely high. Here they are exaggerated, but still they are high. Now, the left model, we'll see what the seismic pad makes. Again, waves start to diffract inside the pylon. Vibrations occur, but they are much smaller than in the first case. Actually, they were smaller in 4 times than in the first case. So the idea of placing seismic pad made of stones works as well. The bridge withstand strong earthquake that occurred on 8th June 2008. Intensity was about 6.5 by Richter scale. The epicenter of the earthquake was about 36 kilometers from the closest pylon, and the bridge withstand. Nothing was destroyed except a couple of peripheral piles that were repaired. Actually, there were new piles that created barrier along damaged. And now, how to get protected from different types of waves for buildings or other structures. Presumably, the first known type of that kind of protection is due to Frank Lloyd Wright, American architect, who created Imperial Hotel in Tokyo. The complex was built by the end of 1923, and at the same time, Great Tokyo earthquake took place. Half Tokyo was destroyed, along with buildings nearby the hotel, but hotel survived. Nothing was destroyed. You may ask why, and the next slide explains it. Here you see what geological investigation shows. Beneath the foundation, there was an ancient swamp. During ages, swamp became a silt mass that prevented S waves from penetrating the building. So presumably Wright knew or thought that that can be helpful under earthquake, under wave actions. And he, in spite of digging a huge hole, a huge pit for foundation, he decided to put foundation just over the swamp, and the idea worked. Now we tried to explore that idea for modern buildings. Here is a reactor building of the nuclear power plant that resembles one that was constructed in Taiwan. We placed several granular, they are called metamaterials, beneath foundation of the building, placed that compensator shown in green color here, launch earthquake, as waves begin to travel, they come here, that pad begins to work, compensators begins to work, but the building remains stable and safe. That shows how that idea works. The other idea associates with actually the same seismic pad, but applied for skyscrapers. We have here two skyscrapers. One is protected. You'll guess which one. The other one was left as it is. Again, we launch earthquake. It generates S waves. They come to the buildings, and you see what is going on now. Now, wave comes to the building. Here are strong deformations, strong stresses, and here are only small one. And actually, if earthquake is sufficiently strong, the building can collapse. And that will survive. That was seismically protected with a seismic pad. And now some benefits of seismic pads filled or seismic barriers filled with granular metamaterials. The first benefit is broad frequency band. Actually, what is known, traditional seismic isolating devices are tuned to reduce vibrations at some particular frequency or relatively narrow frequency band. In contrast to them, seismic pads are designed to protect from a broad range of seismic frequencies, actually from 2 Hertz to 35 Hertz, or maybe higher or maybe lower, depending on requirements. Then less cost than most of traditional seismic isolators. The use of acoustic metamaterials ensures high reduction ratio for magnitudes of all types of the seismic waves, comparing with more traditional solid and elastic fillers and at a lesser cost. And now, which is also more, extremely important, their higher durability. Metamaterials used for filling seismic barriers are made, or seismic pads are made of melted inorganic materials as basalt materials or granite melted materials. This ensures maintenance of the normal working conditions for more than 250 years. That is on par or exceeds the estimated life of the buildings and structures. And actually, the last slide. Thank you for your attention.
Okay, thank you very much. I think we have a bit of time for questions. There is a question, Sergey Vladimirovich, from one of our speakers, from Borislav Christov. He's asking, what kind of software complex was used for simulation?
We use actually two different complexes in Taiwan, ANSYS, in Russia, Abacus.
Okay, thank you. I think it's clear enough. And one more question from Tashkent, from our colleague. Thank you for an interesting presentation. That's a comment. And question is, how do you explain the increase in the number of earthquakes in Asia over the past 3 years? Can you hear me? How would you explain the number of earthquakes in Asia over the past 3 years? Due to what? Climate change, or form of energy, etc. Thank you.
That is not my assessment. I derived all data from known sources, from geophysical sites where these data are presented. Actually, there are a number of geophysical sources containing a lot of numbers on earthquakes, their energy in the origin and depth of the origin and so on.
Okay, thank you very much. And one more question from the same participant from Uzbekistan. Do you take into account the wave entrainment of energy from structures to the ground? I hope you got the question.
Well, I think we account that because finite element codes allows us to simulate well, almost a real environment with diffractional waves, with scattering waves. So I hope that reflection of wave energy from foundations is also accounted.
Okay, thanks very much. I think so we can proceed. Thank you very much for a very interesting report. We can proceed to the ultimate speaker for today.
Okay, thank you.
Yeah. I'm ready to announce, so Dr. Yaroslav Rybak, PhD, Assistant Professor, Faculty of Civil Engineering, Wrocław University of Science and Technology, our colleague from Poland. Is he present in the audience at the moment?
Yeah, I think so. Can you hear me?
Yes, we can hear you well. Yeah, I will announce that the topic of your report is time as a decisive factor for control procedures in geotechnical engineering. Thank you.
Okay. Could you give me the possibility to share the screen to show the presentation?
Yeah, I think so. The previous speaker has to close. Sergey Vladimirovich, could you stop sharing screen?
Yeah.
Thanks.
Sorry.
Okay, so I will try to open my presentation now. If only I managed to start from the beginning of it. Once again, welcome. It's really a strange situation that we all meet online, but I hope it will not disturb us in understanding and following our presentations. So my subject is the time as a decisive factor in the case of control procedures in geotechnical engineering. And it's very much related to the our current practice as engineers, also as consultants on the building sites. And it seems that Sometimes the role of time, the meaning of it is underestimated. It's obvious that everybody is always in a hurry on the building site. Everybody wants to have the answer and the testing procedure done immediately. But I just wanted to underline some issues which are related to time that cannot be neglected in the case of control of foundations or embankments or other kinds of geotechnical constructions. I prepared briefly the list of related issues, and they have to start from the time from work completion to the moment of testing. It means we start from the time that we have to devote to wait for the construction to set up, let's say, until we can test it to obtain the value which will be binding, which will be important, valid for the final stage of the construction. That comprises the pile capacity testing, when we have to consider the concrete strength and the soil setup around the pile. Pile integrity testing, when all the low strain methods, they rely on the wave velocity, so we have to wait until the time when the velocity in the concrete is established. It usually takes around a month. Then we can discuss the strength and stiffness of soil cement composite, also depending very much on times, and depending in another way that we are used to in concrete. As soil cement composites, like all the deep soil mixing, cutter soil mixing, jet grouting materials, they gain the strength in a different way than concrete, for example. They are not standardized at all. Everything depends on the soil, on the amount of the hydraulic binder, and so on. Again, we have to consider the role of the time of the testing itself. It means that keeping still an example of foundation piles, we all know that we can do a static load test and the dynamic load test. The dynamic load test, if we do not consider the time needed for the assembly of the construction, but still it is very short, yeah? It is within a second. The static load test takes hours and sometimes days to get the proper result. In this case, we may discuss the number of tests that we can do in a certain time on the building site versus their credibility. And also, in the case of static load test, we can consider the importance of making it in the whole range of load, because sometimes we finish after 4 or 5 hours, we do not apply any more load, and we say that, okay, we can use some of the extrapolation methods. Many scientists discussed it throughout the decades, let's say, and we have many hints how to get the final result out of the limited information. I will try to show you an example that it doesn't work that well as we might expect to. And again, we have this time and range of performance test. Yeah, I told about it. Control procedures for embankment compaction testing, meaning the quality control of earthworks. This is also geotechnical engineering. It's preparing the ground for, let's say, roads, for railways, also for foundations, for example, when we need to build the fields. All the control procedures take time, and those which are based on deriving the density index or some other indices concerning the density of the ground skeleton, the humidity, and so on, usually take a long time because of one thing, just because of the time needed to check the natural moisture of the ground. And I have one example to show you how to avoid this. Again, time is crucial when we speak about the results of the analysis. Because yes, we can do tests very fast, and then we can wait for weeks with the providing our report to the building site, and they need it for maybe for the observational method, maybe for some kind of active design, like coming back with our results to the computation model, and maybe for this updating of this model on the basis of new data. Only the black parts will be presented in the preceding part of my presentation. Okay, main features. In our tradition, we have the code of practice, which says that in the case of the cohesive soils, we should wait for a month. In the no matter of the technology. Concerning the technology, in granular soils, capacity testing can be performed faster for driven piles as they are internally ready for loading. Yeah, so they do not need any more time for hardening. Static load test takes a lot of time and money, in fact, but it's a very reliable, and it can also be done as a reference test for other methods. Like we can do static load test for a reference for many other dynamic testing, for driving analysis, for example, for the analysis of piling reports, for example. Yeah, why the time of testing is so important? It's just because when we do it after the completion of works and something goes wrong, then we need to strengthen the foundation, and this is not easy. In this case, it's just an example how the group of driven piles, of bored piles, sorry, was strengthened by the group of driven piles, which had much lower stiffness and capacity, but they provided two additional values. First of all, they could carry part of the load. Secondly, driving of the driven piles improved the quality of the non-cohesive soil around the bored piles, the big ones, and that gave, let's say, a double profit. We can rely to some formulas describing the gain of the capacity in time. Usually it's a kind of a logarithmic relationship. It was given by Skov and Denver, people from Denmark. And if we assume a typical value A equal to 0.2 for sand, we can just, for example, calculate that within a few weeks after the completion of works, in between the 5th and 55th day, the typical gain should be around 17%. 17 is not much, but this is just for sand. And as we all know, the reconsolidation of the ground around the around the pile in the sandy soil doesn't take a long time because the dissipation of the work pressure is easy, yeah, in sand. I have some results. They do not confirm perfectly the theory, but you may notice that comparing the blue value, which is the end of driving, the brown value, which is test after 1 week, and the yellow value is testing after 2 months approximately, we can really find that the average increase is around 26%. So, of course, in this case, in another case, this could be 16 or 20. Anyway, it works. But not always so positively. We have an opportunity to test piles for the bridge foundation in Poland, in Policko. It's northwest part of Poland. And you see two graphs concerning the load displacement relationship. If we speak about the capacity, the capacity of an early test, according to our code of practice, will be somewhere here. The capacity of the later test after a month, as it should be done, is a bit higher. So then, according to the code of practice, we could observe some kind of increase of capacity. But the new Eurocode relies on ultimate capacity. And for both of those piles, the ultimate capacity does not differ much. It is not much over 2000 of kilonewtons. And if you look at this graph, you see that the observed increase according to our code of practice can be around 15, even 20%. But if we rely to the ultimate load, and then we use the Eurocode procedure dividing it by the special factor, then this increase is not really significant. It is around 1 to 4%. Speaking about piles in clay, in that case, the matter of time, and this time needed for reconsolidations, is much more important. Going to, oops, maybe I'll push this somewhere here. Going to the results, we can observe that around 2 weeks may give an increase of around 50 or 60%. So this is really a big thing. Piles in clay should not be tested too early, just in order not to bring unpleasant discussions to the building site, because no supervisor will allow that. On the other hand, we can always count on that if something goes wrong, we may ask for repeating the test after 2 weeks. Well, I don't know any buildings which were built in 2 weeks, so the pile will never be loaded so much within such a short time, and that gives us an possibility to how to call it, to save the situation. Theoretically, for the example given, the increase should be around 67%. We measured 59. So speaking about the typical accuracies that we meet in geotechnical engineering, I think it's very, very accurate. In here, you can see just a set of results, very old results taken 15 years ago, but the observed increases in capacity for the piles starting from the end of driving day to the moment where they were tested are usually measured in many, many percent. However, in some cases, we have negative values even at the decrease of the capacity, which is very significant. And it should also be warning for all of us not to rely too much on theories. Speaking about the integrity testing, the accuracy of integrity testing is briefly based, so maybe in here, is based on the velocity of the elastic or acoustic wave in concrete, in the material of pile. So as good as we can measure the velocity, as good we can derive the final length of the pile. I have a funny example. Maybe first I will start from this graph. These are results of back analysis of concrete wave speed velocity in between the 5th and the 12th day. Of course, this relationship should not be linear, because it's not linear, but anyway, we can observe two important things. First of all, that it increases. Secondly, that the diversity of the result is relatively high. So whenever we have a discussion about the real length of the pile, we can provide an information that it's not only the matter of the length, it's also the matter of the accuracy of the method, which should be somehow established. And I just wanted to introduce you a very short and funny situation that happened to me on a building site when I went to test a pile. Integrity testing is just measuring the time which elapses from the initial hit to the pile head and the reflection that we can measure after a certain time. That gives us the way that the wave traveled back down and back to the top. Anyway, I was asked to measure the length of the pile. I said around 10 meters, and everybody was very worried because it should be 9. So after some discussions, we finally found out that the age of the pile is just a week. And after a week, the wave speed is not 4,000 meters per second when that I assumed as a default value, but it's just 3,300. And that gave an exact value of 9 meters. So even a guy who is said to be a specialist, like a Mr. Doctor from the university, can come to the building site and make a mistake without any bad intention, of course, just misinformed about the age of the tested construction. There are a big number of relationships proposed by various scientists all over the world, like Amir, Fino, Gazman. They all gave some recommendation concerning the wave speed in the concrete. And I must say that I also gave some recommendations, but I do not rely much on them because they simply differ on the concrete quality, concrete grade, and so on and so on. So anytime it has to be assessed individually. This graph shows two things. First of all, that it increases in time. This is another set of results in between the 12th and the 33rd day, but it also shows this diversity. It is not very accurate. The results of a back analysis of wave velocity are not in a line, but they form a cloud of results that we can, of course, present as in a form of a formula. But giving this formula, we always have to speak about its accuracy. What is the, let's say, standard deviation of the results, or better to say, the coefficient of variation. And to measure this coefficient of variation, we made a test of 12 piles on the building site, which we had an opportunity to test for several days. So these are the results: day 6, day 7, day 8, day 9, so on. After pouring of the concrete, after the completion of the piles, we measured the wave velocity, and then we could establish something which was the most important thing for us. It was this green value, I mean the coefficient of variability. This is how much we are mistaken. It is not how much the operator of a machine was mistaken making a pile. It's not the mistake in length. It's a mistake in testing method. So if it's just 3–4%, it's not a big problem, but this 3–4% may mean around half of a meter in the case of 10-meter long pile. So this is something that we should always remember. Again, as reliability analysis are very much developed last years, they are very in fashion. It's a hot topic in geotechnical engineering. So these values can also be checked or considered as basic variables for some reliability analysis. So we made some histograms, and also this is again the increase of acoustic velocity, but those results were given in this histogram graph, showing how they are split on the 7th day, on the after 3 weeks, and after 5 weeks, I guess, plus minus 1 day, because they were not all tested exactly the same day. As you can see, the increase can be observed of the velocity, but the almost normal distribution of the results can also be observed. We tested it using this test of normal distribution, and you can see that it does not differ much, no matter if we speak about the 1 week or 5 week old pile.
Yaroslav, sorry to interrupt you. You have about 3 minutes to complete your presentation.
Okay, I will speed up. So this is all about piles. Now about deep soil mixing methods. This is not so important. It is always important to know when to test the deep soil mixing composites. We did some tests, as you can see, preparing of a sample, some concrete grade, cement grade, and so on. All the samples were tested in the compression machines, and we derived both the final strength and also the elastic modulus, which was established without this bedding error. We didn't care about this part much. We also did it in unloading, reloading to have the second value, and those graphs are important. It means that the soil cement composite must be considered individually, just because it's very difficult to give any recommendation concerning the behavior in time. As you can see, some of them stopped to gain strength after 4 weeks. Some of them were still in progress of strength after 3 weeks, 8 weeks, and even 12 weeks. This is very important because it depends on the cement and on the soil, both. This is about the elastic modulus, the same conclusion. I like this graph because it shows that various cements manifest the best work, the increase, the gain of the capacity in the cement concrete composite, depending on the ground and on the cement. And it is not much dependent on the time. As you can see, all these graphs look the same, but this one is completely different from this part. This is the sim 2, this is the sim 1. So they have another moment when they start to work properly. This is about the elastic modulus and compressing strength, not so important. As I don't have much time, I will just skip the description of the methods, but I just wanted to show you how much can we be mistaken when we try to derive too much information from a limited information from the building site. As you can see, this is the part of our load settlement curve. When we try to measure its final ultimate capacity, it's going to be somewhere here. But if we reduce the number of points and we neglect the last one, this will bring us up here. If we lose one more point, it will bring us up here with the ultimate capacity. So reducing the information, shortening the time of the test can lead us to the overestimation of the results with something like 20%. On this graph, we proposed here some kind of formula to how to derive the error. But these are all the measured values, measured and then processed by means of extrapolation methods concerning capacity and brought to one chart. And here you can see, if we do the test till the ultimate capacity, then we are 100% sure. If our information is limited to 90% of this value, then our error will be just 3%. Doesn't matter. For geotechnics, it's quite good. But if we perform only 50% of the final derived value of the capacity, then our mistake, our average error average, it's not the biggest one from the test, it can reach 35%. So this is absolutely unacceptable. And just to end, we did, concerning this COVID problem and the lockdown, we had an opportunity to work with students in our labs finally, because our labs were closed. So we did some testing comparing the microwave drying and standard air dryer, which takes around 1 day to dry the soil samples. And as you can see, this microwave testing gave us a very proper results after 10 minutes. For various grounds, that was the anthropogenic crumble from the mining industry, that was standard medium sand, that was a clay, just a moraine clay. And for all those grounds, surprisingly fast in the case of the clay, we could measure the humidity, the moisture content very, very fast without big mistake. This is important. And some conclusions, just to end. Concerning the pile capacity testing, expect capacity increase, but in time, but do not rely on that. It means that in most of the cases it will increase, but not necessarily. Concerning pile integrity, wait to be sure to measure what you think you do. About strength and stiffness, you like it or not, it must be individually tested. The possibility of interaction between various cements, additives, and various grounds is so big that it's very difficult to make any recommendations. I know that the construction company, they gather thousands of results and they are able rely to those databases, maybe some neural networks, yeah, to establish some relationship, but so far that is doubtful. Finally, time and range of performed test. Well, you get what you pay for. If you pay just for the half of the test, then you get half of the information. No need to rush. And concerning this accelerating procedures for moisture content, time of reaction is bigger value than percent of test accuracy. It means that in most of the contracts, it's better to use microwave just to give a fast answer, like you can proceed with the works, or you can proceed with the compaction of this layer, because the stopping of the works is not a good idea. Well, it seems like it takes a lot of time to talk about time. Sorry for that. I know that I took all of my time credits. Time is money. Money does not guarantee happiness, but shopping does. And I guess, as I was the last speaker, it's time for a break. And this time for a break should be always acknowledged. Thank you very much. Thank you, Moscow. Thank you, Hanoi.
Yes, thank you very much, Yaroslav, for a bit of humor as well. I think for those who fell asleep, they just woke up. All of them, thank you. Okay, unfortunately, again, we don't have any time for question and answers, and I need to make the final announcement of today. Okay, I would like to thank all the guests and participants for joining us today, and especially for those who watched it till the very end. Okay, and what I would like to announce, tomorrow we'll have a section sitting, and the time will be from 10 up to 2 p.m. It's Greenwich Meridian Time +3, from 12 up to 4 p.m. Greenwich Meridian Time +5 hours. And so another round is from 2 up to 6 p.m. It's Greenwich Meridian Time +7 hours. And it's all will be done by Zoom, as you know, and the full information about how to join those section sit-ins will be sent to you this evening. Just check your email and so log in. So we'll be happy and delighted to see you tomorrow in our sections. And that's basically it. And also log in on the conference website, where all the information with schedule about the work tomorrow is uploaded. That's it from me. Hello from Moscow once again to all our colleagues.
Many greetings from Berlin, and thank you very much for the nice presentations.
Yes, lovely. Thank you very much. Bye now.
Bye.